Very good evening to all of you. So far, only 27 participated joined. Okay. Once again, good evening to all of you. Now the time is 6 p.m. We will start our fifth day program. Today, the session 9, um, electrical vehicle manufacturing opportunities for India. The expert address going to be given by Dr. C.G. Saravanan, Director, Professor of Annamalai University, Chidambaram. Before that, we all know the various guidelines of ATAL FDP. 80% attendance is compulsory and 70% of marks in the final test, that is tomorrow test, is mandatory to get the FDP certificate. So I request all the participants to recap these 5 days, various expert lectures, and also go through that and get yourself energized to make it convenient to get more than 70% in the test. Test is not little bit tough, not it is easy. It is designed as per the requirements of AICTE guidelines. So I request all the participants to be prepared well enough to get the certificate of ATAL FDP. And a lot of people are telling good evening, and I already told once again my happy evening to everyone who has joined in this. And participants, they raised a query tomorrow at what time the session starts, is exam time, everything. So we have sent you the schedule. I just brief you what are the necessary changes done in the timetable. And today, session 9, 6 to 7:30 p.m., Dr. C.G. Saravanan is going to handle. Session 10 is going to handle by the co-coordinator, Professor Dr. Vijayan sir. And the topic is challenges in rural electrification for EV infrastructure. Due to the industrial expert domestic reason, we are unable to come in the online. So with the proper permission and approval from AICTE, this minor changes has been done. And another important point is, tomorrow the session starts by 2 p.m. I request all the participants to be alert by 2 p.m. Saturday, after the lunch, 2 p.m. session starts and session ends by 8 p.m. Session 11 starts by 2 to 3:30 p.m. That is battery technology and recycling challenges, which is going to be handled by Dr. Krishnaveni, postdoctoral fellow, Tokyo University of Science, Tokyo, Japan. She is going to handle that session. After that, session 12 is 3:30 to 5 p.m. The sustainability and carbon footprint reduction through EVs. That session is going to handle by our senior most, the expert and the authority in the field of energy, the professor of mechanical engineering and former vice chancellor of Anna University, Dr. Velraj sir, is going to handle that session. The session is number is 12 and the timing is 3:30 p.m. to 5 p.m. After that, session 13 is there. In that session, the topic is consumer perception and acceptance of EV. That is going to be handled by Dr. Vijayan sir. And after that, the session is 5 to 6:30 p.m. And most sought after your question, lot of questions you asked in online. The thing is, online test and feedback is by 6:30 to 7:30 p.m. 6:30 p.m. to 7:30 p.m. After that, 7:30 to 8 sharp, we are going to close the session. 7:30 to 8 is the valedictory session. Okay. This is a small modification in the timetable. And after the online test, if any of the participants willing to give feedback, kindly post your one-page PPT, your photograph, your affiliation, your name, and your education qualification and our achievements in our participants WhatsApp group, so that it is easy for us to call you one by one during the feedback session. And the same PPT is going to be displayed in the online, so that all the participants will get benefit, who is going to give feedback and what is their valuable feedback. Your photo will be displayed and your name and affiliation and your achievements will be displayed. So like what we are presenting the expert one-page biodata, you have to give your details in one slide, so that it is easy for us to call you one by one, so that we will finish the session by sharp 7:30 p.m. 7:30 to 8 validity session. Again, almost only 42 participants are there. Professor? Professor, good evening, Professor.
Good evening, Saravanan. Is it audible?
Yes, sir. Yes, sir.
Professor, good evening.
Good evening.
Sir, your voice is not audible.
Good evening. Good evening.
Professor, your audio is not coming.
Audio only.
பேசுறாரு ஆடியோ வர மாட்டேங்குது. இல்ல பேசுறாரு.
Hello.
For us it is audible, audience.
Audio.
சுரேஷ் இதுல வால்யூம் பாருங்க.
Hello.
Professor, now it is audible.
Okay.
Professor, 1 second, I will welcome you. Slide, sir. Yeah. Once again, we welcome Dr. C.G. Saravanan, sir, Professor and Director Mining of Annamalai University, Chidambaram, for the 5th day program of Session 9, Electric Vehicle Manufacturing Opportunities for India. Once again, I am happy to introduce Professor Dr. Saravanan for the August gathering. Coming to the education qualifications, Professor has completed his highest academic degree PhD in the area of IC engines and alternative fuels in the year 1999 from Anna University, Chennai, and ME Thermal Power from Annamalai University in 1992, E Mechanical Engineering, Madras University in 1988. Various achievements of Professor Dr. C.G. Saravanan, sir. Total number of publications 140. Index H index is 22. I-10 index is 51. Total number of conferences are 42. Total number of research projects completed as of now 10. Total research grant received from various funding agencies like DST, DRDO, UGC, NLC is about 3.06 crores. MOU with NLC India Private Limited, Neyveli in 2017 for formulation of academic program Diploma in Mining worth about 8 crores. Total number of programs organized, various programs like faculty development program, conferences, seminars, symposia, workshops, more than 25. So far, Professor has guided, awarded thesis count is 25 in numbers, and 8 professional membership bodies in the Combustion Institute, USA and SAE. Also, worth mention that Professor is the authority not only in India but at international level in the field of IC engines, alternative fuels and type emissions. And I personally visited his university and his research laboratory. He has invested huge crores of money to carry out the research in the field of IC engines, alternative fuels, and energy technologies. I request the participants, if you find time, please visit Professor's laboratory so that you will get an idea of what IC engine research going in what direction. On behalf of AICTE online ATAL FDP program, I welcome Professor Dr. Saravanan sir, CG Saravanan sir, the Professor and Director of Mining Department of Annamalai University, Chidambaram, to enlighten us on the topic of electric vehicle manufacturing opportunities for India in the session 9 of 5th day AICTE ATAL online FDP program, Friday, 31/1/2025. Professor, we welcome you, Professor.
Yes. Welcome, Saravanan. Thank you very much, Dr. Saravanan. He is a very close friend associated with the past 20 years. Very vibrant and dynamic personality. Say wherever he go and occupy the key posts, immediately conducting these kind of programs. If you organize any program, I am one of the resource person of his program. Once again, I thank that principal and management authorities give me an opportunity delivering on FDP program. Energy electrical vehicles in India, opportunities, challenges, and features. 2 days back, I delivering a lecture on design on electrical vehicles. Now, the slightly topic is changing. Electrical vehicle manufacturing opportunities for India will be there. Say any electrical vehicles, there are important components are there. Battery, number 1 is called battery. Number 2 is called as a motor. Number 3 is called as a charger. Only these 3 components will be there. Whereas in the IC engine having n number of components are there, n number of systems are available. We have to change that design and modification, everything will be there. But in case of electrical vehicle, only important source is a battery. Important source is called as a battery. That battery, what is happening already explained, it is a lithium battery will be there. Lithium ion battery is there. And some of that R&D groups are working low cost R&D, the lithium battery are replacing some other materials are there. And motors also similarly, and conversion of AC to DC, DC to AC, and charging also carried out by renewable energy instead of electrical energy will be there. So these 3 components will be there, major opportunities, biggest challenge for India for electrical manufacturing. Sure. So in the electrical manufacturing vehicles, the biggest challenge for number 1 important. Is it audio visualize that PowerPoint presentation, Saravanan?
Yes, sir. Yes, sir.
Yes, sir.
Now it is showing the title slide, sir.
Sir, that is electrical vehicle again and again. There are 3 components, major components of electrical vehicles: battery and motor and charger and converter. That's all. So number of persons will be increases or decreases depending upon the usage of batteries and ampere hour of the battery and running of the electrical motors. So these are one of the 3 key important parameters will be there. So some of the slides I am going to explain today. We conducted one case study, DST PERS program. It is sponsored by Department of Science and Technology. The total cost of the project about 15 lakhs. It is a multidisciplinary project. Mechanical engineering myself and electrical professor Babu and computer science Asigla. These 3 people jointly involved in this electrical vehicle project. Total cost is 15 lakhs. So we purchased this 14-seater electrical vehicle from Chennai. From that, it is modified in the top roof. We have to do some solar panels will be the solar stickers in the top roof will be the number 1 modification. Number 2 modification, what is happening will be there. This is a converter. The converter is converted into modified into split converter. So in the split converter will be charging forward as well as in the reverse direction. Number 2 modification. Number 3 important modification, the charging of battery not done by electrical energy. The solar panels are arranged in the top roof of the building. From the panel, it is converter and then battery will be there. So these 3 modifications will be carried out in this project will be there. So this is a capacity of 14 passengers. So traditionally, this electrical vehicle using for golf stadium and some other hospitals transfer the patient in inner to outer, outer to inner, and some other education institution using for going in and around of the campus. And finally, it is nowadays it is using for most of the railway stations. If you look at this seater, passengers will be travel from railway station to inner to outer will be there. So this is the application of that this vehicle will be there. You can see this is a 14-seater. What is speciality of in this vehicle? It is a power steering. Number 1. Number 2, water coupling will be there, and mechanical brake is eliminated using as a modified hydraulic brake is number 2. Number 3 is a lithium battery will be there. There are 2 numbers of batteries are there. One is for charging in the daytime. Another one is for running the vehicle. That is a number 3 modification. Number 4, the suspension will be completely modified. That is called as a leaf type suspension will be provided. Also, telescopic shock absorber will be provider will be there. It is a 14%. Approximately 1200 kg load bearing capacity will be there. So now I am brief about what are these structures, starting from battery, converter, motor, and drive mechanism, and what is the speed mechanism, and the important thing is a suspension. And finally, we discuss about what is called as and the tire, what type of tire can be applied in this entire electrical vehicle. It is only a case study. We going to a couple of months going to submit a report. There are 2 phases of work is completed. One is converter, that is called as a split converter. Forward direction also doing, reverse also direction also doing. Number 1. Number 2, charging is done by renewable energy. So the 2 phases are completed. And the third one, the roof of the vehicle we are pasting at the solar panels. From the solar panel, charging the battery will be there. So last phase is about to complete. After that, submitting a report to DST. Yes. The tension.
Sir,
what are the key components? Battery, AC induction motor, and charging system will be there. You know, aware of that. 2 days back, I am delivering the lecture on lithium-ion battery will be there. Same battery will be there. We are not manufacturing any lithium battery. It is imported from the China. The cost of the battery will be there 5,000 rupees. There are 2 batteries are there. Approximately 10,000 rupees will be there. Major cost of the component is battery. Second one is called AC induction motor. We are doing indigenously, that is AC induction motor, rotor, stator. There is no brushless motor will be there, and commutator. These are the basic components are indigenously done by AC induction motor. And charging system. Charging system is very important. It is a new novelty by means of a renewable energy charging the battery. In the panels are mounted in the top floor of the building, and it is connected to the converter to the battery will be there. Yes. So you can, if you look at the slide, the operating voltage is 9.1 to 12.1 voltage. What is the delivery current? It is a 45 amps will be there. And surge current 180 amps will be there. Maximum duration will be 5.5. And what is a charging time? That is a plate weighted load. It is a 2.25 hours will be there. So maximum distance travel with the help of that ampere hour, maximum 70 kilometers per day will be travel. Seating capacity is 14%. If it is a full load condition, maximum delivering of current will be only for 70 kilometers. After that, we got a charging again carried out by 2.5 hours. If you look at, this is called as a battery number 1. This is battery number 2 will be these are the lithium battery. We are not manufacturing lithium battery. It is imported from the China will be there. It is made up of lithium ion.
okay.
So now working principle of the battery, I just recollect. We know that what is called positive plate, LiOMO2 will be there, electrolyte lithium ion will be there, and the carbon is called negative will be there. This is a red color indicator oxygen, and the violet color metal ion, and lithium ions are there, and the movement from positive to negative will be there. We are having one separator will be there. To avoiding the short circuit, we are providing separator. It is a semi-solid battery will be there. Maximum in high energy density material, the atomic number is 3. So it is very, very light, easily to compact to place a battery in the roof of the electrical vehicle will be there. So it is a very fundamental and basic things of the working principle of the battery will be there. Yes. So what advantages? This is important key terminology. We are having lightweight, high energy density, rate of charge will be less will be there. In a greater number of charge and discharge of the cycle will be there. In the absence of memory effect, discharge completely. Operating voltage from approximately 37.7 volt will be there. So these are the silent features we are using as a lithium ion battery. So involving risk, if you are overcharging, overloading will be there. Sometimes it is a blast. Last presentation I explained some of that mobile phone, some of that gadgets completely blasted because of overloading, overcharging will be there. It is a cost. The cost of the material, again, it is depending upon that. In India, very few places will be lithium ion is available, particularly Rajasthan is available. In not very abnormal is resources available in Himalayas. Now in near future, in the cost will be come down. So still we are 90% lithium ion batteries materials are imported from the China will be there. So complete discharge damage the battery. Very high temperature is very quickly discharges. Short span will be there. And what is happening finally, standard all the sizes will be there. But highly cost effective. Very cost effective. But another side having high energy density material, quick charging, quick energy will be releases. So these are the silent features about the lithium ion battery. So now, second important component, this component is manufacturing in India, in Bangalore, and some other component manufacturing in the Coimbatore. This is AC induction motor using this vehicle. So normal power rate is 4.9 to 9.8 kilowatt. Current rate is 36 ampere hour. So this is a maximum capacity. That's why it is called AC induction motor. Delivering overload will be the maximum output 10 kilowatt. The frequency 12 to 200 hertz. Operating voltage from 75 to 145 volts. Delivery torque will be there 10 to 65 Newton. The speed, that is important parameter. It go up to 6000 RPM per minute. The winding will be 3-phase. This is the important component. If you look at the slide, this is what is called battery. That is called as a motor. This is called as a differential will be given. It is mounted in the rear axle. So it gives the different speed will be there. This is called as a AC induction motor. So these components will be manufacturing in India will be there. So what are the motor cars are using in across the various automobile indices? Taycan 160 kilowatt, Chevrolet 149, Jaguar 147 kilowatt. In Hyundai Motors 137, Nissan 110, Renault 100, Hyundai Motors 90, Mercedes-Benz 300 kilowatt. What is car using? It is a maximum capacity. The Mercedes-Benz will be there. So that the vehicle will be travel up to 400 kilometer one single charge. So without any modification, we can travel, we can go for Benz vehicle, it is a 300 kilowatt, Telsa 285, and Audi 140, Mahindra 30, Tata Tigoro, it is 30, Mahindra 18.9. So it is a Mercedes-Benz and Telsa, these are US based companies. It is highest rating of a motor will be there. So rest of the companies we are giving what is the Tyler 160, Chevrolet 149, Jaguar 146 is there, Hyundai Motors 90 will be there. So maximum induction motors capacity played vital role. The distance traveled, the vehicle will be there, quickly charging, quickly discharging. On the process, it is completely depending upon the motors. Yes. So how the controller working? The driver press the accelerator pedal. What will happening in there is a potentiometer. It is going for controller. From the controller to 300 volts, and the AC motor to transmission to the rear wheel will be there. So what is the voltage of battery? 12 volt. After that, from the controller, we are getting some portion of energy will be there. So that is called as a regenerative braking system. And during the kinetic energy and the excess energy will be returned back to the charger will be there. Yes. So now this is a charger for this electrical vehicle. The cost of the charger will be what is 3,000 rupees. It is approximately 3 hours. What is the cost of that charger? Approximately 400 rupees will be needed. 300 to 400 will be there. Using this charging of battery will be there. Now, what are the challenges will be there? This is the challenges we going for renewable energy charging. Number one will be there. Build efficient vehicle will be there, reducing the consumer footprint. Number two, user collaboration with the education institution. And user when the using the charging mechanism will be there. This is a total grid will be there. So these are the big challenges to solve. You can see 5.7 kilowatt hour per day electricity, average household. So far, 40 kilowatt capacity by consuming 6 to 7 hour volts of the time. So 1/3 of the energy will be consuming in the e-vehicle battery will be there. So what is the remedy for that? Going for a renewable energy. So these are the technology available: solar panels, battery, and sometimes we are getting the wind energy and the load system, electrical grid. From the electrical grid, we are giving to various terminals of the number 1, 2, 3, 4, all the charging, individual electrical slot. So again, this is the panel. The cost of the panel is 10,000 and ampere is 8 watt, 8 ampere hour, 30 volt will be there. So this is the panel. I will show you the next slide what we done in indigenously charging system of this project. So this is an important thing. We done indigenously in this project first DST scheme. This is a solar panel 1, 2, 3. So one panel is a 30 volt, 8 amps will be there. Cost of the panel is 12,000 rupees. It is placed in the 3rd floor of the Annamalai University faculty building will be there. The pipelines, this is a wire connection is given. Wire connection is to solar to DC distributor box. From the distributor box to the converter to the lithium battery will be there. So approximately during the sunshine period at 10 o'clock to up to 1 o'clock, we start that renewable energy capturing in the solar panel. It is active only 12 to 1 o'clock. The 12 to 1 o'clock the battery will be completely charged, fully charged of the battery will be there. So this is indigenously we are developed in the R&D of the charging system done by the solar energy, not going for any electrical energy in this project. So comparative analysis, performance, efficiency, motor driven by, and much better than engine driven vehicle, extremely environment friendly. So performance wise, efficiency of the motor vehicles and the engine environment friendly, that is more important one be. Main disadvantage e-vehicle, lack of capability of storing of sufficient energy in the battery. Again, it is coming under storing of battery. So the battery is an important part of the component, and the storing means charging and the discharging. These both the processes are very tedious. That is a major disadvantage for the period of and under cyclic charging. Energy storage capacity battery very low compared to the conventional fuels. You are using conventional fuel, high power, high thrust will be there. We go run the vehicle high altitude. If you go to Ladakh, we go to high altitude places in defense applications. You are using still in the fossil fuels. So light segment vehicle, mid segment vehicle in the flying surfaces done by e-vehicles are there. So because of that, fossil fuel import will be reduced. Number one. Number two, what is happening is the environmental pollution. Pollution is very toxic, particularly various capitals of India, Delhi, Mumbai, Calcutta, Chennai. These are highly polluted. So within the city, run by battery mode. And then cross the limit, we go for a fossil fuel mode. It is a hybrid concept is introduces in near future. So still EV vehicle manufacturing automobile industry due to problem of storage capacity of the battery, unavailability of nationwide network and availability of the material will be there. All the automobile industry shifted towards manufacturing e-vehicle. For example, two-wheeler segment and electrical motors will be there. And what happening will be there? N number of engineers, automobile engineers are downsizing. So immediately sent out from the automobile industry. It is a big question mark for automobile industry. People will be there. So that in automotive industry, as a society automotive engineers have slowly replacing that conventional fuel to electrical vehicle for light segment and medium segment. And the cost analysis. Cost analysis, size of the battery, reduce alternative energy, and the onboard installation of renewable energy. This is a new terminology, new innovative ideas. Power bank plays a electrical vehicle management, extra fleet coverage. When vehicle moves along with against air resistance, air mass hits the body, the vehicle can generate electricity. So new strategy using renewable energy, wind turbine installation and converted to kinetic energy and the mechanical energy. So in this vehicle, we did one experiment. On the front side of the vehicle, we are putting a turbine. In the forward motion, the turbine getting a energy, high velocity will be there. 2 meters per second to 5 meters per second. Again, it is depending upon the vehicle speed. That wind turbine is coupled to the battery. With the help of that turbine, the battery will be completely charged. The subsequent slide, I am going to explain what is the current technology for the charging method. Yes. So now this is indigenously we developed. This is applied for project for tiny. One of my colleague got about 25 lakhs from Tamil Nadu government will be there. Now this is called as a turbine. It is placed in the front side of the vehicle. It is called as a diffuser. So in the forward motion of the vehicle going inside will be that we are getting high kinetic energy will be there. So you can look at this is a turbine blades. This is a turbine blades and the air is going inside narrow blades. The pressure drops, velocity will be increases to 2 meters per second, 4 meters per second, 5 meters per second. From the velocity area, it is charging the battery will be there. So this is a technology developed by our department staff. Apply the funding, he got the also funding. About to patent this technology will be the charging done by wind energy, not renewable energy. It is completely depending upon wind energy. It is depending upon the vehicular speed. Subsequent slide, I will show you the numerical analysis of the what are the speed at which traveling, what are the time duration for battery will be charges. Yes. So wind turbine system. So this is a wind turbine system, onboard energy and electrical vehicle auxiliary unit. Develop a model, dynamic response on vortex induced wind turbine. It is a vortex induced wind turbine. It is placed in the front side of the vehicle. In this work, modeling and simulation based upon the onboard power generation under power system, dynamic condition present. And it is not static condition. Static condition, there is no charging. Once in the vehicle is moved forward, it is called dynamic condition. The airflow rate is increased from the turbine. It is coupled to the battery. So dynamic behavior wind power generation analyzed starting a map noisy vibration wind condition and using the software simulation running the condition. Next. So what is the working principle of the wind turbine? The turbine is designed capture the kinetic energy of the present in the wind, convert into electrical energy. What is that? Kinetic energy. The kinetic energy is converted into the electrical energy. So analogy and drawn between wind turbine conventional generator unit which harness the kinetic energy of this thing. The modeling standard point fixed speed turbine consists of a following components: turbine and blade assembly. This is a prime mover. Shaft and gearbox and the charger. Permanent system. It is a generator and control system. Now, what is the methodology adopted for charging from the wind turbine? The wind speed, wind turbine, gearbox and management system and power electronic and DC sources will be there. Turbine blades start rotating, wind pass over the blades, the wind mechanical power taking input to the speed and the permanent synchronous generator is connected to the wind turbine through the gearbox. That is important component generator. So from the wind, the generator is running. From the generator, it is coupled to the battery will be there. The generator mechanical power is input to that permanent synchronous generator and produce electrical power with help of permanent. Numerical power system simulation tools or power systems will be developed for modeling work. Proposed platform implement the model for the permanent and the synchronous generator base will be there. So magnet synchronous generator depends upon the magnetic attachment rotor of the generator and the stator of the generator. 6 oil coppers are there, windings are there and fixed in the respective places. The rotor has permanent and connected to the beating and the rotation. And what is the wind turbine? In the wind turbine generator not required any DC supply. Important thing is there is no DC supply. Excitation circuit do slip and contact the brushes. The machine can be superior alternative traditional of induction motor that can be coupled with the turbine, diesel generator used for hybrid vehicle. So this is important thing. There is no need for power supply of the generator. With the help of a wind and the kinetic energy, and the generator is a rotator. From the generator producing electric energy, that energy is converted into chemical energy. So environmental expert recommended permanent generator reduce the impact of the pollution. Main thing is reducing cost of the electrical energy and reducing the environmental pollution. So now we can conduct a case study. Case study, we are running the vehicle 10 km per hour. And what is the distance? What is the duration? What is the wind? And 20 kilometers and improving steps 4.9. From the 4.9, the charging rate is 1 amps, 2 amps, 3 amps. It is a 5 amps. It is a 6 amps. It is a 4.5 amps will be there. So from the wind velocity, the ampere hour will be there. So if you look at the table, 10, it is only velocity 2.2 because vehicle speed is very low, 10. It is increasing by 10. It is double. It is going about 4.96. If it is look at 30, it is 7.8. corresponding wind velocity equal to ampere hour, we conduct a survey. 2E is equal to 1 amps, 4 is equal to 2 amps, 7 is equal to 3 amps, 10 is equal to 4 amps, 13 also 3.5 amps will be there, 16 also 4 amps will be there. So this is the case study of the trial run will be conducted within the campus. So what is that? How to measure the speed? We can using the anemometer. That is important instrument to measure the speed of the air will be there. Next slide. What are the design process involving the electrical vehicle? If you look at video. Saravanan. Hello. Saravanan. Hello.
Professor, சொல்லுங்க professor.
Any questions so far? We completed 3 components. One is battery, motor, charging. Because charging is done by indigenously. This is pure R&D. And
Yes, sir.
another thing is called as a converter. Last part I am going to explain.
Yes, sir.
I am going to explain. Okay. Any questions as of now?
Participants, is there any questions or clarifications? Participants,
No, Saravanan.
so professor சொல்லுங்க.
என்ன லைவே இல்லையே லைவே இல்லாம say there are two important components will be discussed. One is charging done by solar energy using in that and wind energy concept charging is done. Okay.
Yes.
This is a two indigenous technology we applied project. We also getting some funding. If having any doubt, I will share my things. Otherwise, I will move on to other section.
Participants are telling that no questions, sir.
No question.
No
Then there is
question,
no
sir.
life.
You can proceed
no
for
que-
next further class.
Okay. Very good. That's fine. Okay. EV system. What are the systems are there? Almost these systems are more pertaining to automobile engineer, mechanical engineer. As of now, steering. You know the what is a steering system? What is a braking system? Acceleration system, suspension system, wheel system, and chassis body system, and electrical system. So these are the important systems are there. In the e-vehicle, what is the steering will be there? Is this power steering will be there. Small motor will be applied. The steering is very effective will be there. Power steering. It is similar to the automobile will be there. Similarly, the braking system, what is a brake? And then not disc brake, hydraulic affected mechanical brake will be there. And brake also are there. What is a gearbox? We move the vehicle forward gear, stop the vehicle ideal, and R for reverse. That's all. Only 3 positions of the gearbox will be there. And acceleration, we have to press the pedal. We can go up to maximum 60. Maximum 60 speed limit will be there. And the suspension, leaf coil will be there. Coil type will be there. And wheel system also we are having, and toe in, toe out will be there. Chassis, it is a tubular chassis material. I will show you the subsequent slides. And finally, electrical dashboard. What is that? Voltage, ammeter, speed, and analog and digital type of the charging system is available. So these are the various systems configuration of the electrical. Next. So now I am going to discuss about rack and pinion type steering system, right and drive with the electrical power steering will be there. These 3 things are available these electrical vehicle. Number 1, rack and pinion. If you rotate the vehicle clockwise direction, the vehicle will be rotated in this direction. If you rotate the anti-clockwise direction, the vehicle is going in the other side will be there. So that is called as a rack and pinion. And electrical power steering. Electrical power steering, even separate motor will be there. The drive mechanism will be there. You can easily to drive the steering wheel. So less effort will be there, and the drivers will be there. There is no drag at all. So comfortably turning left side or right side, and easily to reversibly we can taking in with the help of a power steering mechanism. Yes. So what is a power steering in this electrical vehicle? Angular turning of a front wheel multiplied by the driving effort, leverage mechanism, and turning fairly easily function of the steering wheel. That is important. Turning of the wheel easily in the function of a steering system. So without a driver much effort, less drag, to move the vehicle from left side to right side to left side. So what is advantage? The wear and tear of the tire will be what will happen, life will be enhanced. To reduce the wear and tear will be there. So that's why in this vehicle using for a power steering mechanism. In order to prevent the road shock and terminator, passenger steering system also provide a shock absorber. Another shock absorber mechanism. Well, moving bouncing action and that steering wheel can be move up and down will be there in this electrical vehicle. Next. So now this is that you can see this photograph. This is a steering wheel. This is steering column will be there. This is the indicator switch will be there. Move from left to right all the direction. This is a rack and pinion. If you rotate, the pinion will be moving in the rack. Left to right, right to left. You can see this is a rack, this is a pinion. The same concept will be applied in that electrical vehicle. That's why rack and pairing steering system. Now this is a power steering. Here we are using hydraulic, but in this electrical vehicle using for the electrical motor to easily move the vehicle left to right, right to the right. Less effort will be there. Driver's drag will be reduces. The life of the tire will be increases. Next, so next system is called as a braking system. What type of brakes are there? Four-wheel brake system, front hydraulic disc brake, rear hydraulic drum brake, hand brake will be there, booster braking, electrical braking, automatic slow down prevention, roll back on the slope. We're going for slope surfaces, automatically slow down the vehicle. See, these are the components available in this electrical vehicle. These components we are manufacturing in India. Number of companies are in and around Chennai and Coimbatore. We are doing all kind of. It is similar to that automobile will be there. There is no much variations. Now you can see this is a drum brake available in this e-vehicle. This is a drum. This is asbestos rope will be there. This is asbestos rope will be there. The pad will be moving outward. The drum will be rotating in the clockwise direction to stop the vehicle. This is called as what is called as a brake off position. That is called as a brake on position. Brake off position is a gap. There is no contact between shoe and the drum. Here, the shoe and drum contact each other. That is called as on position. That is asbestos material. Again, it is a conventional method. That is also asbestos material. These are coil springs are there. This is a drum will be there. The drum is attached in the wheel. Now, how it is working off the shoes will be there. It is a leading shoe and this is trailing shoe. This is a plunger will be there and the plunger can move outward. It is applied and reducing the speed will be there. So this is called as a leading. That is called as a trailing shoe will be there. This is a leading. This is a trailing shoe will be there. So these are the basic concept of a braking system. These components are already manufacturing in automobile industries. The same component will be effectively implemented in this electrical vehicle. Now you can look at these are the component removing the electrical vehicle. Electrical vehicle, this is called as a pad. The pad will be completely replaced. What I like? You have to remove the net and top surface will be replaced by new one will be there. To applying the lubricating oil will be there. With the help of the hammer to fix the drum will be there and finally fix the tire will be there. So this is called as a drum brake. The drum brake concept will be applied for all electrical vehicles. So now it is hydraulic brake. This hydraulic brake also effectively applied for almost all electrical vehicles. The hydraulic pressure in this, what is happening? The shoe will be moving, leading and trailing will be there. This is hydraulic. This is a cross section will be there. It is a brake oil fluid will be there in this e-vehicle. You have to periodically check the level of the lubricant. The lubricant passing through the piston. The piston, while pressing the accelerator pedal, you give more pressure through pressurized lubrication. That is a brake oil going for a wheel cylinder. From the wheel cylinder, the shoes are expanded outward. While releasing the pedal, the shoes are come back to the original position. So earlier, it is completely mechanical. Now it is with the help of hydraulic, to driver's effort will be minimized. The braking effect will be the more accuracy will be there. The braking distance and thinking distance very short. So more accuracy to stop the vehicle, precisely stopping the vehicle. If you visualize any object across the road, immediately apply the brake to stop the vehicle. There are two pedals only in the electrical vehicle. One is accelerator pedal. Another one is a brake pedal. There is no clutch here. It's automatic transmission. One is forward gear and reverse gear and ID. So this is the conventional system is three pedals: accelerator, brake, clutch. Here only accelerator and the brake will be there. So these are the hydraulic brake system effectively implemented for the vehicle. So with the help of hydraulic fluid, it pressurized and moving outward, moving inward to stop the vehicles. So now this is a brake. What is a brake? Parking brake. It is a completely mechanical brake will be there. Now you can see, look at, this is a rack will be there. To pull the rack upward, what will happen? The brake shoes are move outward to stop the vehicle. while parking. After that, while driver on the vehicle, what will happen to release a parking brake and start the vehicle? That's why the dashboard one indicator will be provided. Suppose it is handbrake, it is on position, very difficult to start the vehicle. So absolutely sometimes the driver on the vehicle. So that technology is implemented in the e-vehicle. So immediately red light when they off, that is, it is reaching the on-off position. So this is a rack through which the pull the driver, move up and move down will be there. This is a cable. So the cable at which what will happen, the shoes are move outward, the shoes are moving forward will be there. So it is a linkages. This is a two cables are there. Two cables, one is for one wheel, another wheel for that. This is a rack. The rack at which what is called in the pinion is what is called brake is released. The brake is set. What is called the brake is released, moving up. The moving down, the brake is set. Brake is set means the complete rest of the vehicle. Now, if you look at the electrical vehicle, so this is handbrake. This is a gearbox. Only forward gear, reverse gear, and neutral will be. That's all. There is no what is called separate clutch system. It is automatic transmission will be there. Yes. Similarly, what are the suspension? So main suspension you are giving shock absorber. All electrical vehicles, front suspension, rear suspension, suspension provider for a vehicle comfort. The vibration shock will not transfer to the passengers. That provide a discomfort of the passenger. The suspension played vital role. What type of suspension? It is a leaf spring will be there, coil springs will be there. Some of the advanced vehicle air bellows are using. In this vehicle, there are two types of suspension. One is coil, another one is laminator spring. This is also manufacturing by automobile industries. Yes. So now if you look at, this is a e-vehicle. The e-vehicle, this is a laminated spring will be there. That is a rear axle. This is a tire. This is a laminated spring will be there. Laminated spring or lengthy spring. Next one small size. Next one further small. And for further small will be there. So if you look at, this is the suspension. This is a one eye. That is another eye. It is located in this chassis of the vehicle. Number of leaf will be there. While applying the load, it becomes flat. While there is no load, what will have bend section. So there is a leaf structure will be there. It is one of the conventional system acting as a good suspension for the electrical vehicle. There is a less cost. There is no need any maintenance at all. So now this is a spring will be applied for automobile. That is a e-vehicle. It is a coil type spring will be there. The axle load will be applied. It is compression. The axle load is removed. Again come back to the original position. It acts as a shock absorber. So this is the shock absorber, very commonly used for almost all automobiles are there. The e-vehicles are specially used for their small size of shock absorber. This big size is a conventional vehicles are there. The small e-vehicles are this kind of, this inner, we know aware of that. It is a lubricant oil will be there. Small orifice will be there. The piston is moving down. What will happen? High load will be absorbed. Through orifice will be what will happen? The liquid is going outer walls. So that period, what will happen? Absorbing the shock will be there. It is called as a telescopic action will be the compression and the expansion is there. So this is independent suspension almost provided for automobile. There is no dependent suspension. We can look at the conventional vehicle. One vehicle is bound. This shock and vibration is transferred to the entire body. So the vehicle will be tilt. If you look at independent suspension, one vehicle is bound, nothing will be happening in the other wheel. Other wheel is in the horizontal condition. There is no tilting, there is no vibration at all. So it is independent suspension will be provided almost all vehicles. So these are the systems available. I hope this system is effectively implemented for electrical vehicle. Yes. Next. Next. So and finally we going for a wheel. What type of wheels are you are using in that electrical vehicle? MRF and cheap. What is the cost of the tire will be there? For 5,000 rupees up to 6,000 rupees will be there. In my electrical vehicle, some medium segment vehicle is up to 8,000 rupees, 9,000. It is a tubeless tire will be there. It is a tubeless tire will be there. It is similar to that automobile and the electrical vehicles having the tires. Next slide, what is the cross section of the tire will be there? Inner play. Again in the top layer play, further top layer, that is a threads are there. That is a tubeless tire will be there. It is a buttons are there. The thick rubber will be provided. We are to observing how much layer will be there. Thick rubber material will be there. Inner we are having wire will be there. Here the two sides will be wire will be there. Steel rope will be there. So the steel ropes in the holding the wheel of the automobile will be there. So this is steel wires or these are cross section details. So now the e-vehicles are using for some other high altitude application, some other in the bad weather condition. If you go to US, some of the Sweden, some of the European countries and Canada, it is a very hot, coldest climate. It is 32 degrees and 22 degrees minus. So that is the case, more slippage will be there. To avoid the slippage, you are providing some buttons. You can see, if you look at the thread, 10 metal buttons are there. What is the role of the metal button? You are giving friction. You are giving more road grip will be there. Instead of putting the chain, you are inserting the buttons will be there. So this is a condition at which using for that vehicle for testing the snow surfaces, slippery surfaces, using for these kind of tires. Now we come to the real chassis of the automobile. This is called as a 14-seater e-vehicle. We can look at these two main supporter will be there. There is a two main beams are there. All other structures are tubular material. All other structures are tubular material. Is completely welded, arc welding and gas welding is done. Completely what is a cross beam will be there. Backside rim will be there. This is a seat. This is a seat. This is a seat position will be there. The cross beam will be there. And the horizontal beams are there. Two complete running beam will be there. It is a heavyweight material. This is a two things are heavyweight. Other structures are completely tubular structure will be there. Very, very lightweight material. That's why e-vehicle having less weight will be there, so that it can move very fast and consumers of battery energy will be very low will be there. It is a tubular construction. So now this is a manufacturing unit of a e-vehicle chassis unit. You can see this is a front side. The fronts all are tubular material. That is seat number 1, seat number 2, seat number 3 will be there. Inner side and the battery will be provided. This is a cross beam 1. This is a cross beam 2. Number of structures are there. It is a welding, only arc welding and gas welding in the tubular structure. Beside the high load, actual load will be there. And load carrying capacity approximately 1200 kg will be there. 14%, average weight 80. So you calculate it, how much load will be there, this vehicle. So the vehicle is moved in the speed breaker and the cavities ups and down. This material will be absorbing shock and vibration with it. This is called as a chassis unit. If you look at that video. Previously. This is the crossbar. Here, what will happen? Slight bounds will be given. The two sides will be there. Because or what will happen? Overhanging. The distance of the span will be very high. That will be one step will be provided. Here, this is a lithium battery. This is a AC motor. This is a converter. Complete manufacturing unit of a e-vehicle. I think. Stop. This is a lithium battery. It is imported from China. This is a AC motor. This is a charging unit. This is a suspension. Now, finally, we go for an electrical system. In this e-vehicle, if you look at the electrical dashboard unit, that number 1 is our kilometer. The maximum kilometer of our vehicle only 60. Maximum 60. That's all. Now we are giving what is called ampere hour. What is ampere hour? We are giving maximum 8 amps. 30 amps will be there. What is that? 30 amps will be there. And similarly, this is called as a voltmeter. What is common? Voltmeter will be there. 20, 30 amps, it is up to 60 volt will be there. There is 3 units. This is indication. This is a charging capacity of that battery rating. 55% will be there after 1.5 hours. So after 3 hours only, it is a battery will be fully charged. Analog digital instrumentation, combination of switch, better display indicator. This is the indicator. So this is called as a typical power electronics. So what is called 3-phase supply? The battery will be there. Bidirectional converter. You are going with a 3-phase motor and a transmission system. It is going for a unidirectional converter accelerator system. This is one of the circuit involving for electronic gadgets for getting the energy, whatever energy spent by the battery will be there. So these are the different types of motors. What are the motors? We are going AC and DC, universal, synchronous and variable, asynchronous, squirrel cage, wound motor, stepper motor, and trapezoidal, sinusoidal, permanganate, switch reluctance. These are the various motor classification. We use in this case study, we are using AC motor. This is a motor will be the, and brushless DC motors are used, brush and without brushless. So these are the advantage going for AC to DC motors. So design of bi-directional converter of electrical vehicles. So before going to that, we ask some question related to the chassis and other things. Saravanan. Hello. Hello, any questions? Hello. Saravanan is audible. Any questions from our audience?
Yes, sir, you are audible.
Yes. Any questions as far as
Correct.
chassis and important thing?
Correct.
You can see the
Correct.
manufacturing unit.
Thank you, sir.
The
Thank you, sir.
manufacturing unit of the e-vehicle in Chennai. We take some photographs, we give a design. After the design, we get the vehicle. Saravanan, any questions?
Let me check the
Ah,
chat box. Participants, is there any clarification or questions or queries?
No, sir.
yeah, what is always no, sir?
Nachimuturaja, no, sir.
And then at least one or two people have some questions. I should be very happy. I should good interaction with them. Otherwise, continuously during the lecture, there is no use.
Dear participants, the expert lecture should not be a monologue one. It should be a two-directional one. Please get some clarification, or it need not be a question type of thing. Any clarification, any research idea, please raise your voice.
Battery vehicle video
Nachimuturaja, please clarify your doubts.
At least Saravanan, you will ask some questions. At least the coordinator ask some questions.
Yes, sir.
Yes,
sir. Sir, yes, we all understand that the new concept of EV is going to dominate the entire scenario in future. But in layman point of view, I have a clarification, Professor, because in a middle level family and low level family, for example, they have a two-wheeler of a low level family, and middle level family, they have a, for example, say Maruti 800 car, which runs on gasoline, petrol fuel. 10 years back, they might have been purchased for 3 lakhs. Now it's worth, after 10 years depreciation, it will be only 30,000. But an electrical vehicle costs more than 15 lakhs, a mini electrical vehicle. How the average people will have affordability for this, sir?
So basic thing is important component is lithium battery. See, the import of lithium battery will be reduced automatically. What will happen? The cost of the vehicle will be reduced. See, I have shown different components in a electrical vehicle. Am I right? See, only that lithium battery only 10,000 to 15,000 will be there. What is the life?
Yes,
maximum 2 years. After 2 years, you got to spend how much? 15,000 rupees. So you got to replace some lithium battery to some other material. Number one. Number two, mass production, the cost of the lithium battery will be reduced. Number two. Number three, the availability of lithium material abnormally very high level in Himalayas, Rajasthan will be there. As an engineer, metallurgical engineer, and mining engineering people to excavate all the material and convert into lithium material or replacing some other lithium to some other material. So that is one of the best method. Saravanan, what I telling is you are an IC engine man. Why don't you using for ethanol? Very cheap, very cost wise, very cheaper. E10,
Yes,
E20 will be
yes,
Indian government is permitted. If you go to Sweden, E90 will be there. If you go to Brazil, E95. Your guide is 12 to 20 years back. Still, we are not
Yes.
implemented. Why? Yeah, why it is going for battery? The availability is less, cost is very high, recycling is
Yes, sir.
very tough.
Yes, sir.
These 3 points are very weak points. Why don't you try? It is at least we go for hydrogen. Hydrogen is excellent fuel, renewable fuel. See why we are almost all of a sudden all the automobile industry going for e-vehicle. See, okay, if it is good for two-wheeler, no issue. Okay. If you go for all the vehicle for e-vehicle means what is happening? You can imagine what happening in the IC engine people. What happening will be the automobile industries. Here there is no thrust at all. Am I right? It is very
Yes, sir.
problem will be there. Very low thrust will be there. You can very speed. What is the speed? Maximum 40 kilometers. You have to charge for 3 hours.
Yes, sir.
3 hours we are going for only 70. If it is go to Hyundai Motors, 250 kilometers, it need 2 hours. It is superchargers are available in across the country. That is very cost is 50 lakhs, 60 lakhs will be there. That is important. We are not doing any manufacturing of components. I am showing almost all components, steering, gear, tire, these things will be manufactured in India. I will show
Yes,
the videograph of the chassis. It is done by Ambattur. Chennai Ambattur, this vehicle is fabricated. So what about lithium battery? Again imported from China. What is it? The cost? Cost is double and triple will be there. Every day we can using any electronic component, charging and discharging will be there. Similarly, in the battery also, charging and discharging will be there. If you are keeping a more than 1 week, what will happen? The battery will be dead. Same IC engine, nothing to happen.
Exactly, sir.
Sir, what my suggestion is better go for ethanol or hydrogen. Instead of going for all of a sudden the e-vehicle technology. Everybody tell e-vehicle, hybrid vehicle, plug-in hybrid, series, parallel, so many things will be there. That is good. What is the cost effective? As sir, you mentioned, the Ratan Tata introduced Tata Nona car. Why? The two-wheeler 4 or 6 persons are travel. The Tata is absorbed. He manufacturing a small auto like a car. That is a Tata Nona car. The cost is 2 lakhs. It got to 4 lakhs. Now finally the closer plant will be there. That now Tata Nano is completely going for a e-vehicle. E-vehicle technology will be there. Transferring of IC engine to e-vehicle will be there. So my suggestion is what available in India is a renewable energy. Agriculture country. Abnormally available what is called solar energy will be there. Am I right? From starting from
Yes, sir.
March, April, May, June, July, and January, February, 6 months approximately sunshine is very high.
Yes, sir. 6 months it is
Sun,
abundantly available.
available. And going for wind energy. All right. Or going for ethanol. Most of the sugar mills are sick will be there. We give opportunity for that sugarcane industry people. So you got to think in that direction. As engineers, we got to think in this direction. So availability also not available. All things are imported. And naturally, what will happen? The cost is very high. It is a monopoly.
Yes, sir. Sir, one more school of thought from my side, Professor, a small submission to you. Going for EV is very good for the environmental to safeguard our mother nature. But at the same time, already we have millions of vehicles that run in Indian roads using gasoline and high-speed diesel oil. Immediately what we can do means, one is, as you rightly told, going for alternative fuels like ethanol and all. And also to take care of after treatment process, as we have told in so many FDPs. This will also will take care of the mother nature, since treatment to be given inside the engine cylinder, we are doing it outside the engine cylinder before going to allow the atmospheric combust air into the atmosphere. You treated and then send it to that. Then also environment will be taking care and safeguard.
Say, Saravanan, I will tell you, I visited so many countries in Korea, Japan, and some of the European countries. Within the city, better run by what is called battery mode. You cross the city limit, run by IC engine. Say, whatever energy spent, you get back the energy. In Korea, strictly implemented. Within the city, highly polluted. See, knobs, socks, everything will be there. Because every signal is 60 seconds. You wait for from Tamra to Panic Canal, there are 10 signals are there. 10 into
Yes.
60 seconds, you can calculate. The vehicle is running in ideal condition. The vehicle running ideal condition, CO will is abnormal in petrol engine. Similarly, the
It will
NOx
emit
will be
more.
high. Yeah,
Yes, sir.
you can run by better battery. Battery mode will be there. Nothing wrong. There is no noise. There is no pollution. Energy saving. Clean environment. Everything is better will be there. So you got to think in this direction. So within the city, highly polluted cities, effectively introduces a e-vehicle. Better if you go to Delhi using all the vehicle CNG, there is no pollution, there is no carbon atom.
Yes, sir.
CNG is very cheaper. Very cheaper will be there. Almost most of the cities nowadays are in my places also CNGs are there. Very cheap. Number one.
Yes, sir.
Number two, environmentally friendly. Environmentally friendly will be there. It is high octane number. So my suggestion is light segment vehicle go for e-vehicle, but within the city go for hybrid mode. ICE engine,
Exactly.
one powertrain, another one powertrain. All right. This is
Exactly.
a technology is better. It is my perspective will be there. So third perspective go for hydrogen. Almost all the cities are hydrogen is it is a very cheaper renewable energy. It is a clean fuel. There is no carbon atom. Running cost less than 1 rupees. In compared to e-vehicle, it is cheaper. Around and compared to e-vehicle, hydrogen is running cost
Yes.
very cheaper.
Yes. And also, as we discussed in so many forums, during charging and discharging, it will pollute the atmosphere.
Yeah. That is definitely, it is a chemical energy. By
Yes.
charging, discharging, some post chemical will be releases. And another important, the household purpose electric energy is not meeting the sufficient energy. If you go for summer, what is the power cut? Maximum 2 hours power cut, 1 hour power cut. It is mismatching supply and the demand will be there. Even
Yes,
though
sir.
number of power plants are there, nuclear power plant, hydraulic power plant, thermal power plants are, it's a high demand will be there. Insufficient energy production will be there. That is the case why you go for electrical energy. Okay, the charging at least done by renewable energy. That's why in our project work, he places a solar panel top of the building, the charging by that what is called as a solar panel. In our the e-vehicle shed, the top is completely filled with the solar panel. Every daytime, one battery will be completely charged by the solar energy. At least these kind of small things done by going for renewable energy.
Exactly, sir. Exactly.
Okay, we'll go the last part. What, Saravanan? We go to the last
We will
part.
go, sir. We will go, sir.
What
To
is
last.
last part is what is a converter? It is done
Yes.
by electrical people. The electrical people is done by dual converters. Dual converter forward also reverse. What will happen? The charging is done. Video photo. It's a bi-directional electrical converter will be there. It is done by that one electrical processor. It is a processor Babu. You have designed the bi-direction of converter will be there. Forward motion also charging, return also charging will be there. So what is advantage? Life is of the battery will be enhanced. It is a purely department of electrical engineering. So far we discussed about the mechanical. So this is a vehicle. The converter is modified, running. What is the charging rate? You see that videograph?
Sir, no video is there, sir.
No video only. Video only. Okay?
No, sir, it is not
Sir,
visible, sir.
not visible, Amma.
Please put it in the sharing mode, sir.
Sharing mode for Sura.
And now it is visible,
Okay?
sir.
Huh?
Visible, sir.
Visible?
Visible. Yes,
Okay?
sir. Visible, sir.
So now we modified the wind generator in the front side. What is the battery charger one? And the bilateral converter is introduced in this vehicle. We conduct a trial run. 6 people, 14 people. What is the charging capacity will be there? வண்டி ஓடலையா? இங்க வண்டி ஓடுது. அது ஏன்டா சிக்காது? சின்ன நாள் சொல்லி வண்டி ஓடல. எடு தள்ளு ஓட்டு. ரைட். Okay, this is the trial run is conducted in this e-vehicle. What is the trial run? The front side having what is that turbine. From the turbine, you are charging the battery. Number one modification. Number two, what is that converter? Bilateral converter will be there. Forward motion, reverse motor, and the battery will be charges. There are two modifications will be carried out. The last phase of the work is the roof portion is stickered by solar panels. It is a sticker. It is a 5th generation solar panel. Whatever you are placed, it is a look at the slide. It is a 3rd generation. Now, latest generation, what is you stickers just placed in the top of the roof. So these are the current technologies are in this vehicle will be there. From the vehicle, we got to do all the things. Now, final modification in this project work, bilateral will be there. Conversion of energy storage into facilities for power flow. Allow the power flow both forward and reverse. That is more important. Earlier converter only forward motion. The reverse is not possible. So as per that direction, you are going for forward and reverse. And batteries get charged during regenerative braking. The regenerative braking means the vehicle is moving the slope surface. More kinetic energy will be there. The excess energy will be charging the electrical energy through battery will be there. That is called regenerative. The highly reliable bilateral converter, namely the buck converter, mostly e-vehicles, but the requirement is very high. Next. So split pike converter. This is designed by our electrical professor and introduces in the electrical vehicle. We conduct a test drive. What is a conventional system and a modified PI converter SPC? What is the charging rate will be there? Very easily charges and quickly energy will be releases. That is advantage. Among the vehicle, bilateral converter, off-pi network, inductance, capacitor are both incurrently EMI, EMC will be the size of the conductor capacity with this grid efficiency. In India, research is SPC. Still in the hardly and actual development of powertrain, controller design, transfer the experimental hardware. So research gap motivated investigation the SPC for the easiest powertraining. So SPC means split pike converter will be there. These converters are not available. Indigenously we have developed, applied in this our e-vehicle to conduct some tests. So this is a BOE design for split converter will be there. This is a minimize F equal to VR and K into CR. Operate both buck and booster mode, thereby enabling regeneration, reversing power flow will be there. That is important thing. Regenerating reverse power flow will be there. The reverse power flow, what will happen? Effectively, the charging the battery will be there. So need not consume the energy. So less energy will be consuming. You are going for split pike type converter. Yes. So in the split type converter, it is using for butterfly optimization algorithm. Again, this optimization, the IT people involvement will be there. This project, mechanical, IT and electrical. These three people sit together, conduct some investigations are there. These part particularly optimization done by the IT department and optimization algorithm inspired for hunting action will be there and involving butterfly with unknown design of the parameters. These are L1, C1 and C2 and the fitness and modeled by the minimize F equal to 1 by all the numerical values. Next. So similarly, butterfly equal to small butterfly, general search of high butterfly, local research of high butterfly will be there. So we are having three categories will be there. The three categories, what are the optimization study will be conducted. So this is a flow chart. You know, we got to write some optimization, we write a program will be there. So the starting command to end command will be there, and the direction bosses will be there. So with this algorithm, you write a program to conduct some numerical values, and the numerical value is a feeding input, and finally what is giving optimum value. So this is ANN based, artificial intelligence based. We are conducting a different node points will be there, different nodes and gateway for the inverter. Next. So in the proposed converter receives the speed of the motor flux, that is important. What is this? Rotor flux will be there. Motor terminal voltage will be there, and current will be there. So voltage VA, VB, VC, and what is the current? IA, IC will be there. What is the input parameters? What is the targeter? During the time of ANN, perfectly map of this, and finally design testing and train the model will perform the training. So this is the outcome of the work. What is the outcome? From battery pack, split converter, inverter, induction motor. You can see forward, also we are getting the reverse. So parameters V output, L1, L2, C1, C2. See voltage in the 10 to 15 volt, voltage output 48 volt. Say 150, 220, 150 and 10 will be there. So this is the design parameter will be there for outcome of the work. Say we can see, if you look at the graph, it is almost flat VB, there is no variation. But if you look at, you get slightly increases 50 and output will be maintained, the constant will be there. So input output voltage forward for the conversion. This is forward. The charging rate both almost flat. There is no variation. Next. Now voltage current L1, L2 stage 1 forward conversion is a moving pulse. One is square pulse width will be there. So corrugated shape will be there. This is a segmental waveform will be there. 0.3 to 0.1 respectively. So sources of conversion forward direction voltage. The voltage almost forward direction, there is no much variation, almost flat. The battery voltage maintain constant voltage 10 volt. Output voltage flatly 3 volt. So voltage ripple was observed 0.06 will be there. So similarly, inductor voltage, current voltage forward conversion. This is 0.01, 0.03 and both up and down version possible SPC. So converter, you can number of switches 2, coupled with the inductor booster 3, trapped inductor 3 and 2 and 4 will be there. And the voltage we can look at 1.25, 1.3, 1.2, 1.05, 0.064 will be there. Next. So this is a circuit designed in the electrical engineering department, implemented in the e-vehicle. If you look at the slide, the performance of drivetrain obtained several operating conditions. Voltage chargeable battery, fixed 37 volt, the converter pumps are boosting and generator 48 volt on the voltage. 37 volt to, we are getting the 48 volt will be there. This is entire photograph. These accessories will be mounted in the e-vehicle. They tested in the lab. What is the current voltage and the reverse and forward converter is boosting the voltage up to 48 volt. So this is at pulse generator boost mode, and that pulse generator buck operation, it is 54 volt will be there. Again, this is a flow diagrams of the voltage frequencies. Yes. This is the inverter output voltage, current specified voltage for full throttle control. The driver crossing full pedal, what will happening will be there. You can see. Off throttle. This is off throttle will be there. The pulse VC will be there. This is off throttle portion. Is a phase reversed in the induction motor. The phase will be changed in the direction. And the finally outcome, ANN control is a 500 watt powertrain, butterfly output 12 volt into 48 volt, obtained design parameter e-vehicle, popularly studied, rising the environmental awareness and the SPC powertrain of the EV and the artificial neural network and the pulse of the power switches. There are some outcomes we are getting. Finally, this technology is applied for e-vehicle. This report is supported to Department of Science and Technology. First one, second phases, and waiting for the third phase. Stickering that roof of the electrical vehicle with the solar stickers and charging the battery. We comparative study will be there, and final report will be submitted. This work will be submitted in the recent IC Engine conference there. We are getting the best paper award for this controller. It is a multidisciplinary approach. Mechanical, electrical, IT people will be there. Okay, this all my presentations will be there. We cover almost in the manufacturing sector. we take a case study of our problem. Problem is one choosing the electrical vehicle, modify the charging system, going for renewable energy, wind turbine, and finally controllability. We cannot changing any battery. Battery is as it is. AC motor is as it is. Inputting these components will be modified. We have to get a new result will be. Thank you very much for your given opportunities. Any queries? Saravanan?
Sir, a question is there, sir. 1 second, sir.
Doctor, good afternoon, doctor.
Yeah.
This is Thirumalan, actually your old student of Annamalai University in the year
Good. I am very proud of you. Your alumni.
96 to 97, doctor. I see, great to see you, doctor.
Okay.
Doctor, if I'm coming for our Indian scenario, if all the peoples are going for an e-vehicle, is our electricity production capacity is sufficient for India, doctor?
No, already is in the summer start, where 2 hours power cut will be there. Okay. It is
Yes,
supply
doctor.
and demand will be mismatching. Okay. If you are 3 hours spending of
Yes,
energy, we are charging the battery. So that's why the charging system completely go for
Yes.
renewable energy. It is one of the best method. In my one presentation, using wind turbine, the front side of the vehicle wind turbine is placed. With the help of the wind turbine,
Yes,
running
doctor.
the generator, from the generator charging the battery. This is one of the cheapest method to charging the battery. We need not go for electrical energy.
Okay, doctor. Thank you, doctor. Thank you, doctor.
One more question from Sahu. What if we use a superconductor in place of the battery?
So almost superconductor batteries, there much variations will be there. So another neighbor's superconductor is in the form of the battery will be there. The efficiency way, performance wise, there is no much variations will be there. Still in the R&D is going on, the superconductor will be there. So better option, instead of going superconductor, going for fuel cell technology, hydrogen based fuel cell technology. That is one of the best method to replacing the lithium battery.
Excuse me, sir.
Yeah.
This is Professor Ganeshan.
Yeah.
I need a small clarification. Actually, when we are putting a turbine at the front of the vehicle, when it is moving forward, there will be a resistance created. So the energy developed by the turbine is more than the energy it consumes to overcome the resistance. How you compensate, Professor?
So the aerodynamic model is design the vehicle. First, resistance will be prevented. We provide aerodynamic shape. And then, and the turbine blades are inward and helical blades are there. It is not a plain blade. So inward helical blades are there. So often it is a less resistance will be there. Even small rotation of that the wind blades, it is a maximum energy transfer to the generator will be there. So it is a trial and error only. We are doing some R&Ds. Finally we got a project.
I appreciate your development that is thinking in that direction, and you make it the use of the forward movement to get the energy. But I feel that some amount of energy which is going to be consumed by overcome the resistance. But anyway, network will be more than the spending. That will be advantage.
Yes, definitely, sir. My object is don't go for electrical energy.
Yes.
Don't go for electrical energy. Using for the natural concept or using the renewable energy concept.
Yes, Professor. Thank you, Professor.
Welcome, sir. Welcome. Saravanan, any questions?
No more questions, sir. Shall we move on to the Thanksgiving session?
Yeah, that's all.
Okay. So on behalf of ATAL AICT online FDP program, and on behalf of Meenakshi Sundararajan Engineering College, principal and as a coordinator of this FDP program, and also joining hands with our co-coordinator Dr. Vijayan, we express our sincere thanks from our core of the heart. In spite of your busy schedule, I know your domestic preoccupation with the larger interest of our country, and to expertise and experience your knowledge to the participants of this 6-day program. You are kind enough to come in online, sir. Thank you very much, officially and personally, for your presence and the presentation, sir. Thank you very much.
Thank you, Saravanan. Give me an opportunity. I will share my email ID to the participant. If you want any clarification, come over here. We do jointly R&D work. Jointly do
Yes, sir.
publication. We take some
Okay, sir.
data with the help of that institutions. Once again, I
Yes, sir.
thank the coordinator and management. Give me an opportunity to share my experience. What are my lab will be conducted in the e-vehicle technology we sharing you. We are not going in-depth analysis of any battery and motor will be there, because that part is a multidisciplinary part will be there. Near future, we are doing some innovation in the fuel cells will be there. Hydrogen fuel cells will be there, lithium cells. So number of work is going on, the fuel cell technology will be there. The near future, even that battery is replaced and fuel cell can be introduced. Once again, thank the coordinator. All the best to participant to carry some useful information. With the help of information, do something in your department, in your institution. Thank you very much.
Dear experts, sir, at present there are 123 online participants are there and witnessed your presentation.
Thanks, Saran.
Okay, sir.
Thank you very much. Thank you for
Right,
all
sir.
the
Thank you very much.
participants.
Okay. Now let us move on to the fifth day, session number 10. I already told that there is a small change in the timetable because of the preoccupation and the domestic urgency. The industrial expert is unable to present his presentation. Instead of that, our co-coordinator, Dr. Vijayan, is going to address on the session number 13, the topic, challenges in rural electrification for EV infrastructure, by Dr. Vijayan, the professor, Department of Mechanical Engineering, Meenakshi Sundararajan Engineering College, and also the co-coordinator of this 6-day FDP program. A brief biodata about Dr. Vijayan. Dr. Vijayan is serving as a professor in our college. He has various research links like Vidwan, Web of Science, Scopus, Archer ID, Google Scholar, ResearchGate, Publoans, etc. Coming to his professional profile, he has completed his Doctor of Philosophy in the area of solar thermal and nanofluid renewable energy engineering, and Master of Engineering in Thermal Engineering and Bachelor of Engineering in Mechanical Engineering. He also do have the certification courses of Diploma AutoCAD and certificates in non-destructive testing radiography level. He is a approved recognized supervisor of Anna University, Chennai. He is more than having 20 years experience, out of which 2 years in the overseas experience in Sultanate of Oman. He do have the 3 more years of industrial experience also. He is having the various soft skills, design expert, Sigma plot, Microsoft Office, Word, Excel, PowerPoint, and ACAD. He has written the books on engineering practices, laboratory and basic engineering. He is having a membership in IFERP, IING, IASC, ISNT, ISTE. He has conducted more number of programs in offline and online in the area of mechanical engineering, particularly the thermal engineering field. Coming to his achievement, he has published more than 12 research articles, 1 book chapter in the international journal SCI, Scopus, Google Scholar Indexed. He is author of 5 international and 2 national conferences in research articles. Recognized as a young researcher in 2022 and a honorary membership granted by the Global Academicians and Researchers Network Forum. Research Excellent Award 2022 by the Institution of Scholars. Recognized editor, reviewer in SCI, ESCI, Scopus, and Google Scholar Indexed journals. Reviewer award and rewards from SCI, SCIE, and Scopus international journals. Editor of our book series of Futuristic Trends in Renewable Energy and Sustainability Energy. He has got the various certification awards and the cash prize for producing good academic results. So far, authored 7 technical books. Worked more than 3 years as a quality control engineer. And he has contributed as a editorial board member and reviewer for various publications At this juncture, we invite Professor Dr. G. Vijayan, Department of Mechanical Engineering of Meenakshi Sundararajan Engineering College, to address the various challenges in rural electrification for EV infrastructure. We welcome you, sir.
Yes. Thank you, sir. Thank you, for respected coordinator, Professor Dr. S.V. Saravanan, sir, for giving this opportunity to be a resource person today. Thank you, sir, and thanks for a nice introduction about me. Thank you, sir.
Welcome, sir.
Now we'll start our session. Sure. Okay, thank you for nice introduction about me, Professor. Thank you. This is the ATAL. So we are conducting from our college, Meenakshi Sundararajan Engineering College, Chennai, Kodambakkam. ASTA sponsored ATAL 6 days online FDP program on energy and electric vehicles in industry in India, opportunities, challenges, and futures. Next page or what? Slide here. Page up, page on. Next. Once again, audience, please. So this program is sponsored by our All India Council for Technical Education and ATAL, organized by Meenakshi Sundararajan Engineering College, Kodambakkam, Chennai, and our coordinator, Professor Dr. S.V. Saravanan, Professor Department of Mechanical Engineering, Meenakshi Sundararajan Engineering College, and co-coordinator, Dr. G. Vijayan, myself, and I am a professor of Department of Mechanical Engineering, same college, Meenakshi Sundararajan Engineering College. Now today is our 5th day and session 10. I'm going to discuss about the topic of challenges in rural electrification in EVs infrastructure. Now we will see the introduction. So rural electrification is crucial for the adoption of electric vehicle EVs in remote areas, while urban regions are witnessing a rapid EV infrastructure development. Rural areas face significant challenges. So this report, what we are going to discuss next, outlines the major obstacles in establishing the EV infrastructure in rural region. For urban region, no problem. In rural region, and the potential solution to overcome these issues and challenges. What are the challenges? We will see challenges in rural electrification for electric infrastructure. We have 7, 8 points are there. One is inadequate power supply and grid infrastructure. And second one is a high initial investment and economic viability. And third is a geographic and accessibility constraints. And fourth one is a lack of awareness and acceptance. Fifth one is insufficient charging infrastructure. And sixth point is a parameters, battery range and performance issue. And seventh is a policy and irregularity challenges. And next one is integration with the renewable energy. These are the 8 parameters which has become the challenges to create the infrastructure for charging electric vehicles in rural side, regional rural side. And first, the first point is inadequate power supply and grid infrastructure. So many rural areas experiencing the unstable or uncertain electricity supply with the frequent power outages. Low grid capacity cannot support high power EV chargers without upgrades. A lack of 3-phase power system limits the installation of fast charging stations. So these are the 3 major points which will affect the inadequate power supply and grid infrastructure. And this is a rural electrification. The first diagram is a rural electrification infrastructure. While making the infrastructure, these are the 4 points of the become the challenges for making this. One is the opportunities, future and direction, solution, challenges. This starts from challenges. And now we discuss about the unstable electricity supply. So unstable electricity supplies, this is because of the limited redundant power lines, frequent transmission failure, long distance transmission losses, overloaded local grids, seasonal variation in electric supply. So these are the 4-5 parameters will affect the will make the unstable electricity supply to the rural regions. So this first one is a limited redundant power lines. So the rural electricity networks often relies a single transmission line, unlike the urban areas that have multiple interconnected lines for redundancy. Second point is any faults such as tree falling on a power line or inadequate equipment failure can cause a complete power outage in the region. The second point is frequent transmission failure. So many rural grids suffers from poor maintenance and aging infrastructure, resulting in frequent breakdowns. Transmission line, transformers, substation in rural areas often fails due to overloading and wear and tear over a period of time. Extreme weather conditions such as storms, heavy rain, high winds can damage power lines, causing prolonged outages. The second point, the second parameter, long distance transmission losses. Rural areas are typically located far from the power generation plants, which increases the transmission losses. And second point, due to long distance transmission, voltage drops significantly by the time electricity reaches end users, leading a unstable supply. And then low quality power with fluctuating voltage and frequency damages the electric appliances, including EV chargers also. Third parameter, overloaded local grids. Rural grids were originally designed to supply a low demand residential and agriculture usages. The addition of EV charging stations significantly increases the demand which existing grid infrastructure cannot handle. And then the power demand spikes, especially during the peak charging hours, can cause the system failures and widespread blackouts. And last parameter, seasonal variation in electricity supply. Some rural areas raise the hydropower or other seasonal energy sources, causing fluctuation in power supply. Dry season reduces the hydropower generation, leading to power shortages and forcing rationing of electricity. Renewable energy sources such as solar and wind and also experience variation impacting the stability of the power grid. So this is the second point or second parameter which meets the issue challenges to the unstable electricity supply. And second point is consequence of unstable electricity power supply for EV infrastructure. Impact of an unreliable power supply of EV adoption and charging infrastructure is significant. Below some of the critical consequences. The first point is damage to the EV chargers and batteries. Voltage, the point is the voltage fluctuation can cause the insufficient charging, reducing the battery lifespan or lifetime and leading to the frequent replacement or displacement. Power surges may damage the charging station components, increasing the maintenance cost also. Second point is reducing the charging efficiency. Frequent power outages interrupt the charging process, leading to longer wait times for the EV owners. Fast charger, which requires a stable power supply, cannot be functioned properly under the fluctuating voltage condition. And next point is higher maintenance cost for charging station. The first point is operators of EV charging station need to install a backup power solution like battery storage or diesel generator and increasing operational cost. Voltage stabilizer and transformers may require to regulate the inconsistent power, further adding to the investment cost. Fourth point is lack of reliability for EV users. If charging station cannot operate consistently, EV users in rural areas may not trust the infrastructure, limiting adoption. So uncertainty in power supply discourages long distance travel in EV through rural region. The fourth point is possible solution to address the power instability. So far we discussed about the disrupted power or unstable electricity supply. So the solution is the possible solution to address the instability. So several measures can be taken to improve the stability of electricity supply in rural areas, ensuring the successful deployment of electricity EV charging infrastructure. The first one, deployment of microgrids. Establishing decentralized microgrids powered by renewable energy sources can reduce the reliance on unstable central grids. The second one is solar and wind powered microgrids with battery storage can provide a backup to electricity during the outages. Second one is upgrading transmission and distribution network. Government and private players or private sectors need to invest in modernizing rural electrical infrastructure. Second one is installing new transformers, substation, and transmission lines will enhance the reliability. Now, the third point is deployment of energy storage solution. Battery energy storage system can be used to store excess energy and provide a backup during the power cuts or power outage. Hybrid system that integrate the renewable energy with the battery storage can offer continuous power supply for EV charging station. So next point is implementation of a real-time monitoring system. The smart grid technology can help to detect and address the power instability issues before they cause major outages. Advanced monitoring and automation system can enable rapid fault detection and repair. Diversification of power sources, expanding the rural electricity generation beyond a single source. For example, integrating the solar power, wind power, and biomass energy can enhance the reliability. Second one is encouraging community-based renewable energy projects can improve the local electricity resilience. And second parameter, low grid capacity. So unstable electricity supply. I have a 2 point. One is an unstable electricity supply, and second one is a low grid capacity. So low grid capacity and its impact on EV infrastructure in rural areas that we will discuss now. So the causes are designed for low demand. So low grid capacity, the cause for the low grid capacity, designed for low demand, aging infrastructure, single phase versus three phases issue, long transmission distances, and But these are the 3 points. We discuss one by one. Design for low demand. So rural grids were primarily built to power homes, small business and farms with a minimum or minimal industrial and commercial demand. EV charging station, especially high power DC fast charger, requires a large amount of electricity which exceeds the available grid capacity. The second one is aging infrastructure. Many rural network relays and outdated substation, transformers and distribution lines that are incapable of handling high power loads. Second one is overloaded transformers and big transmission lines limits the amount of power that can be delivered to charging station. And third point is single phase versus 3 phases. Most of the rural areas have the single phase power only, which is insufficient for high power charging. 3 phases necessary for EV chargers is often unavailable and requires costly upgrades. And fourth point is long transmission distance. Electricity transmission over a long distance leads to voltage drops and energy losses, further limiting grid capacity. Rural substation may not be adequately equipped to compensate for these losses. And third one is impact of low grid capacity on EV charging infrastructure. Here we have a 3 more points. Limited installation of fast charger. So this is due to the inadequate power supply. Only slow AC charger can be displayed, making a EV charging time consuming. So second one is overloading and power failures. So this increases the EV charging demand, can cause the grid failures and outages. Third one is high upgrade cost. So expanding the grid capacity requires investment in new transmission line, substation, transformer, and making rural EV infrastructure development expensive. And fourth one is solution for this low grid solution to overcome the low grid capacity. So first point is grid modernization. So 3 points has to be become the challenging. This challenge has to be resolved. That means the low grid capacity challenge has to be overcome by 3 measures. One is a modernization, grid modernization, upgrading the substation, like already what we discussed, upgrading the substation, transformer, and power lines to handle higher loads. Decentralized energy solution using the microgrid and renewable energy sources like solar, wind, and some other renewable energy sources to supplement grid supply. And third measure, battery energy storage system, BESS, storing excess energy to balance the supply and demand for EV charging station. And so far we discussed about the issue and the solution to overcome the issue. We'll cover the first point, that is inadequate power supply and grid infrastructure. And now the second point, high initial investment and economic viability. So these are this point also important one. This we'll discuss now. Setting up a EV charging station, low population density. So these are the 2 points. Setting up a charging station in rural areas requires a significant capital investment. Low population density results in lower demand, making it difficult for investors to achieve profitability. Limited funding and incentives for private players hinder infrastructure development. There are some key challenges there in setting up the EV charging stations. So first point is setting up EV charging station. There are some key challenges for setting up this EV charging station. The first one is power supply issue. Second one is high initial investment cost. Third one is low demand and economic viability. Fourth one is geographic and accessibility constraints. And next, last one is lack of skilled workforce. Now we discuss about the first point. Power supply issue. In rural areas, often a lack of stable and high capacity power supply. Second is limited 3-phase electricity availability, restrict the installation of fast charger. The second point, high initial investment cost. Setting up an electric EV charging station requires a significant investment in land, electrical infrastructure, and charging equipments. Grid upgrades, transformers, and energy storage system that also add to the cost. Third point is low demand and economic viability. Due to low EV adoption in rural areas, charging station may initially experience low usage, making profitability and concern. Investors may hesitate to uncertain returns on investment. Next point is geographic and accessibility constraint. A remote location may have a poor road connectivity, affecting station setup and maintenance. Sparse population distribution requires a careful planning of charging station placement. The final one, lack of skilled workforce. Rural areas often lack of a trained technician to install and maintain the EV charging station. Now, for any challenges or any issue, there is a solution. Now, the solution for EV charging station deployment. First one is grid modernization. Upgrade the transformer, substation, transmission lines, and support high power EV charging. And next one is renewable energy integration. Using solar powered charging station, the battery storage to reduce the dependence on grid. Public-private partnership, PPP, triple P, encourage the government incentives, private sector investment to reduce the financial barriers. Now, next one is battery swapping station. Offer an alternative to direct charging in areas with unstable power. Strategic location planning. Install power station at key transit points, fuel station, and rural markets to ensure the accessibility. Now, we discussed the two challenges. The third challenge is geographic and accessibility constraint. Rural areas often covers a large distance between the settlement, making infrastructure expansion costly. Poor road connectivity hinders the maintenance and installation of a charging station. And harsh weather condition can affect the performance and reliability of the EV infrastructure. Now, there are certain key points for this challenge. The third challenge, geographic and accessibility constraint. So those key points are large distance between the settlements, poor road and transport infrastructure, remote locations and power connectivity, land availability and cost. So these are the three key points. The large distance between the settlements. Rural population are often spread across the vast areas, making it difficult to strategically place a charging station to ensure the accessibility. Drivers may need to travel long distance to find the charging station, increasing range accessibility and reducing the EV adoption rates. And second point is poor road and transport infrastructure. Many rural areas have the unpaved and poor maintenance roads, making transportation of heavy equipment and installation material challenging. And seasonal weather conditions such as heavy rain, floods, and snowfalls can make the roads impassable, affecting the station maintenance, that is EV station maintenance. The third point is remote location and power connectivity. Some rural regions lack in basic power infrastructure, requiring a costly grid expansion before charging station can be installed. A remote station may offer from unreliable internet and communication network, affecting the payment system and remote monitoring. The next one is land availability and cost. Identifying the suitable land for charging station is a challenge, as a rural land is often privately owned and requiring complex acquisition process. In some cases, landowners may be unwilling to lease their property due to lack of awareness about the EV infrastructure benefits. And these 3 points, issue under the category of geographic and accessibility constraint can be resolved. There is a solution to overcome these challenges. The first one is strategic placement of a charging station. That is to install the station at the existing fuel station, village centers, and highway to maximize the accessibility. And second one is use of solar powered off-grid solution. Deploy a standalone solar powered charging units to reduce the dependency on a distance power grid. Third one is deployment of modular and mobile charging units. Introduce portable EV charging station to service remote area efficiently. And fourth solution is improvement of rural or local road network. Government investment in infrastructure development can facilitate station installation and maintenance. So this is third challenges. Now the fourth challenge, lack of awareness. And here we have a diagram of a rural energy assessment target, and methodology can be completed, type of energy, deliverables, and tools. So all these 5 parameters will coming in the rural energy assessment. And first one, target domestic stores, economic operators, social and the community stakeholders, and government. A methodology can be completed by analysis of economic dynamic vulnerability assessment. The type of energy, case electricity, oil, wood, that is charcoal, and deliverable, thematic map, current and future modeling of energy demand, analysis of energy sources, SWOT analysis of energy access, and some tools has to be used to rural energy assessment. The measuring the electrical energy consumption, geographical information system, comprehensive survey, quantitative survey, a database of reference, and case studies. And this figures will show what are the technology used for grid advantages and shortcomings. So grid extension, energy for productive use, maintenance in principle is safeguarded. And shortcoming, risk of electricity theft, high price of connection for remote areas, and limited willingness to pay. Even higher prices over a difficult fields. Power supply demands on quality of the grid, power transmission losses. So the some of the table shows the country and labor cost and the other cost, material used or material cost and total cost. In case of Kenya, the labor cost and other costs will takes around 6590, material cost 5960, and total will be $12,550 per kilometer. So this is the table shows the cost of grid extension in selected countries, US dollar per kilometer. So each kilometer, these 3 countries will pay different amount or different US dollars per each kilometer. Grid to extend the grid extension, they have to pay around 12,550, 15,960, 19,070 US dollars per kilometer, respectively for Kenya, Senegal, and Mali countries. And fourth is lack of awareness and acceptance. Here many rural residents are unaware of electric EV benefits and hesitate to transition from traditional fuel to electric vehicle. Misinformation about the charging time, battery life, cost creates a resistance to EV adoption. Limited availability of local EV service centers increases concerns about the vehicle maintenance. And there are some like other challenges. Here also some key points of challenges, and one is for the lack of awareness and acceptance in rural EV adoption. One is a limited knowledge about the EV technology. So in this topic, in this title, many rural residents are unfamiliar with how EV works, including battery charging, maintenance, and overall performance. Misconceptions such as EV having low power, short battery life, and being unreliable prevent adoption. Second challenge, a second key point, concern about the charging infrastructure. A major worry is the lack of accessible charging station, making people hesitant to invest in EV. Rural areas often lack in reliable electricity, reinforcing doubts about the feasibility of charging EV conveniently. And the next point, perceived high cost of EV. Many believes EV are too expensive compared to petrol or diesel, which is conventional energy sources, conventional fuel, without considering the long-term saving on fuel and maintenance. Lack of financing option and incentive for rural buyers adds to the affordability challenges. The reason to change and dependence on traditional vehicle. This is the next point. Farmers and transport operators rely on fuel-powered vehicle that have been being used for decades, leading to reluctance in switching to a new technology. EV maintenance center to scare in rural areas, raising concern about the repair cost and availability of spare parts. Now, the third key point, solution to improve for anything we have a solution. So the challenges, for this challenges also we have this fourth challenge also we have a solution. That is the challenge is lack of awareness and acceptance. For this also we have a certain solution. Educational combines conduct the awareness program to educate people about the EV benefits, long-term cost saving, and environmental impact. Incentives, second one, incentives and subsidies. Offer a financial assistance, tax benefit, low interest loan to make EV more affordable. Third is setting up demo centers, provide a test drive opportunities in rural areas to showcase EV performance and ease of use. Public-private partnership. What is discussed already? 3P. Public-private partnership. PPP. Collaborate with automobile companies and local government to promote the EV adoption through the subsidies infrastructure. Next one is insufficient charging infrastructure. Lack of public charging station discourages the EV adoption in rural areas. Home charging requires a reliable grid connectivity, which is often missing in remote location. Fast charging technology is expensive and difficult to deploy without substantial investment. Next one is insufficient charging infrastructure in rural areas. So, fifth challenge is insufficient charging infrastructure in rural areas. The challenges or key points are limited availability. The first one is lack of public charging station, discourages the EV adoption. Thank you, sir. Thank you. EV adoption. So, lack of public charging adoption discourages the EV adoption to rural areas. So, rural areas have a few public charging stations, forcing EV users to rely on home charging, which may not always be feasible. Long distance between charging point make it difficult for EV owners to plan trips without the risk of running out the battery. And next one is lack of fast charging facilities. Most of the charger in rural areas and slow AC charger, it takes several hours to charge an EV fully. Fast charging station requires a three-phase supply only, which is often unavailable in rural, remote or rural locations. High installation cost. So this is because of land acquisition, electrical infrastructure upgrades, and operational cost. So due to the low number of EV users in rural areas, investors are hesitate to establish a charging network and charging station due to his getting of low profit. And grid limitation is also there. Grid limitation and unreliable power supply is also there in rural areas. And so for these key points, and under the challenge of under the name of under the challenge of insufficient charging infrastructure, there's a solution to improve the charging infrastructure. Solar power charging station can be offered, maybe off-grid renewable energy solution to overcome the power supply challenges. Battery swapping system can be adopted. Government incentives can be provided. Subsidies and tax benefits can be given to the investor and private parties, which will encourage them to come into the field. Strategic placements. Install chargers at high traffic rural location like markets, bus depots, and fuel station to increase the accessibility. And next one is and here we have a diagram or a line sketch. We have a central controller. We have a solar panel, a solar powered battery, a solar panel, AC or DC converter, AC-DC converter, central controller, and from the central controller we have a converter. Again, the DC may be converted to AC. You can use it for network. And central bus bar is there. From the bus bar, you can charge. We can get the charge from. We can charge the electric vehicle. And next topic is this is the station EV charging station, which is available in India, some of the places. And this we can call as e-mobility. And sixth challenge is battery range and performance issue. A low distance between the charging points raise concern about the range accessibility for EV users. And extreme temperature in some rural areas can impact battery efficiency and lifetime. So limited access to battery replacement and repair services create an additional barrier. And like other challenges, we have some key points. One is the limited driving range and range accessibility. Low driving range, longer travel distance between the destination, lack of charging station, and these are the challenges or key points will make the battery range and performance. Impact of extreme weather condition. So this is due to cold temperature, hot climate. So this hot climate can cause the battery overheating, accelerate the battery degradation, and reduce the lifespan. Whereas in a cold temperature, reduce the battery efficiency, slow down the chemical reaction within the battery and decreasing ranges. And next one is battery degradation over a time. Lithium-ion battery commonly used in EV degrades over time, leading to a gradual decrease in range. So lack of proper battery recycling and replacement centers in rural areas makes it difficult for users to replace aging batteries. Frequent use of fast chargers can speed up battery degradation, impacting long-term performances. So limited access to maintenance and repair service. So unlike internal combustion engine, there is IC engine vehicle, EVs requires a specialized technician for battery maintenance and troubleshooting. Rural areas often lack of trained professional and service center, making it challenges for EV owners to get their battery checked and or repaired. Heavy battery weight and vehicle efficiency. So EV batteries are heavier than traditional fuel tank, which can impact vehicle handling and overall efficiency, especially in rough rural roads. Heavier batteries also requires more power to move, further reducing the vehicle effective range. Off-road condition, steep inclination, unpaved roads can increase the energy consumption and reducing the efficiency. Next one is high cost battery replacement. High cost of battery replacement. So this is due to significant portion of EV cost, anti-vehicle cost, and limited financial resources, lack of battery, leasing or swapping options. So solution for this, that means to improve the battery range and performance, we have certain points. One is advancement in battery technology. That means you have to go to solid state batteries and high density lithium ion battery and alternate battery chemistries. So these are the two options which is coming out of the battery technology. That means you have to make the advancement in battery technology and expansion of charging infrastructure. That means you have to make the fastest charger and solar powered charging station. Battery swapping station has to be developed. Battery thermal management system, BTMS or BMS, we can say. Advanced cooling and heating system, best charging practices has to be ensured. And next one is government incentives and subsidies. So subsidies for battery replacement and financial incentives to be given to the EV battery buyers. Research grant has to be given to the scientists and researchers, those who are working in this field. Training program has to be conducted for rural people through local EV service center towards the battery repair and diagnosis, and encourage the private-public partnership to make the good network. And next one is next challenge is policy and regulatory challenges, and lack of clear government policies on rural EV infrastructure development, subsidy program focused on urban areas, neglecting rural regions. Complex land acquisition and regulatory approval, delay charging station deployment. And there are some key points. First is a lack of clear and comprehensive EV policy, for rural areas. Most national and EV policies, national policies and state EV policies are designed for urban areas only, not for rural areas. This has to be changed. For rural areas, specific policy has to be framed. And limited financial incentives and subsidies for rural EV adoption, complex land acquisition and approval process, and inconsistent power distribution regulation, absence of battery recycling and disposal regulation, slow implementation of government programs. And solution for these key points, that means solution to overcome this policy and regulatory challenges, rural specific EV policies and incentives has to be created, streamlining the regulatory approvals and uniform electricity tariff for charging station, and strengthening the battery recycling regulation. Next one is strengthening public-private partnership. And these are the solution to overcome the policy and regulatory challenges. And next one is, and here the diagram is given, here the institutional framework, operational and management aspects. So regulatory authority, who is the regulatory authority, who is implementing, what are the advantages, everything has to be policy formulation, who has to formulate the policy, who is benefited, what's the management system, everything is given the table. And next one is, eighth one is integration with renewable energy. So rural area have a potential for solar, both the solar and wind energy integration, but infrastructure is lacking. High initial cost of microgrid and standalone solar charging station prevent widespread adoption. Storage and energy management solutions are still underdeveloped. Integration, there are certain key points are there, or we can say that advantages of renewable energy for rural EV infrastructure. When we carry out we create a infrastructure, rural EV infrastructure, through renewable energy system. There are some advantages. That means overcoming the grid limitation, cost effectiveness, and long-term saving, environmental benefits. And now there are some key points. First is high initial investment cost, energy storage and intermittent issue, land and space requirement, lack of technical and technical expertise and maintenance challenges, policy and regulatory barriers. Potential solutions also, these are the key points, and there are certain, for any issue we have a solution. So there are certain solutions. There is a potential solution for the successful integration of renewable energy system to make the EV charging station. So development of solar powered EV charging station, expansion of wind energy powered for EV charging, implementation of microgrids and decentralized energy system, financial support and policy reforms, capacity building and skill development. So these are the solution to overcome the integrating renewable energy for EV charging solution. So this diagram will show the renewable energy integrated EV charging system. So here you have a gas station. This is the boilers. Here the centrally we have a boiler. This is the thermal system. Gas station, industry, transformer, biogas generation, biodigester, and distillery, photovoltaic. So photovoltaic greenhouse and photovoltaic greenhouse is 2 points exactly. And here the boiler is a major one where the water has to be converted to steam. So to convert the boiler water into steam, we can use the natural gas or photovoltaic electric power from the PV system. So after making the converting the water into steam, you can use it for any purposes to run the turbine or whatever maybe. By running the turbine, we can generate the power. That power can be used. And this is the second parameter we discuss. And before going to discuss the potential solution recommendation, we'll have some small video clippings.
உண்டுல
There's a lesser-known Chinese company taking center stage in the global race to store the clean energy essential for driving the green transition in the U.S. and beyond. This company happens to be the world's largest battery dealer, supplying power for electric vehicles. In the green energy transition. Turning our attention back to China. It's not just sodium ion batteries where they're leading the charge. They're also making waves in another groundbreaking technology, nuclear batteries that can operate for an astounding 50 years without needing to be charged. Betavolt, a startup based in China, made headlines with the revelation of their revolutionary battery technology. They unveiled a battery that can power smartphones continuously for an astonishing 50 years without the need for recharging. This innovation is being hailed as the world's first miniaturized atomic energy system. It achieves this remarkable feat by compactly arranging 63 nuclear isotopes within a module smaller than a coin. The technology functions by converting energy released by decaying isotopes into electricity, a concept that was explored in the 20th century and has now been realized by Betavolt. The startup has initiated pilot testing and aims to mass produce the battery for various commercial uses, such as smartphones and drones. Betavolt's initial nuclear battery provides 100 microwatts of power and operates at a voltage of 3 volts, all while being incredibly small, measuring just 15 by 15 by 5 cubic millimeters. By 2025, the company plans to develop a battery capable of delivering 1 watt of power. The compact size of these batteries enables multiple units to be linked together, boosting the overall power output. Betavolt envisions a future where mobile phones never require charging and drones can fly indefinitely. The battery design prioritizes safety. Betavolt asserts that its layered structure prevents the battery from igniting or exploding when exposed to sudden impacts. Moreover, it can function from a wide range of temperatures, from negative 60 degrees Celsius to 100 degrees Celsius. To craft this groundbreaking battery, Betavolt scientists utilized nickel-63, a radioactive element, as the energy generator. They employed diamond semiconductors to transform this energy. The team created a thin single crystal diamond semiconductor, just 10 microns thick, and positioned a 2-micron thick nickel-63 sheet between the 2 diamond semiconductor converters. Consequently, the decay energy from the radioactive source is converted into electrical current. And that's a wrap for today's video, everyone. Don't forget to give that like button a tap, subscribe to our channel, and turn on those notifications to stay updated on our latest uploads. Thanks for spending time with us. And while you're still around, why not take a peek at the suggested video above or explore what YouTube has lined up next?
Those of us who can afford to acquire electric cars enjoy the comfort of such high-tech SUVs, but how many people know how electric car batteries are made? Only a limited few, I think. As of 2018, there were 5 million new electric cars entering the auto ecosystem, but over the next 20 years, analysts expect this number to hit between 300 to 500 million cars. How will such a staggering number of cars be powered? The answer is obvious. Electric rechargeable batteries. In this video, we will expose the global geopolitics of electric car batteries and how the promise of clean and renewable energy is hanging on the precipice of success and failure at the same time. Electric cars use powertrain batteries that supply energy to all the engine components for the vehicle to function as expected. While the value of powertrain batteries is not in doubt, what is in doubt is the supply chain of these batteries, and most importantly, the raw materials used in producing them. The cost of producing EV powertrain batteries has proven to be environmentally costly, but unfortunately, only very few automakers are taking the problem seriously. The raw material used in making these batteries is lithium and its variants. These variants include cobalt, nickel, manganese, and several other materials. Currently, the material dominating the market is the cobalt manganese material, which is used by many electric auto companies. Tesla, on the other hand, uses a combination of lithium cobalt manganese. The automaker is also working on a new powertrain that will be cobalt-free. However, cobalt still represents the most essential mineral without which EV powertrains will be difficult or impossible to make using current technology. Lithium is made in Argentina, Chile, and Bolivia. These 3 South American nations hold significant deposits of the world's lithium reserves. Cobalt, on the other hand, is mined in Central Africa, in the Democratic Republic of Congo. The DRC, as the country is commonly called, is the world's most dominant cobalt source. More than half of global cobalt deposit is found in this African nation. While a country with such a valuable resource should be better for it, the DRC has become a perfect example of man's inhumanity to man. Cobalt mining is fraught with human rights abuses and slave labor. The exploratory activities also degrade the environment significantly. According to estimates, on every given day, as many as 40,000 children are working in the DRC's cobalt artisanal mines with no safety guidelines in place. Let us not throw into the mix the evil of child labor. In Chile, the effects of lithium mining are being felt across the region as the water-intensive process is contaminating the soil. Lithium mining also poses risks to the agrarian culture of local populations. With all the negative events trailing cobalt extraction, one would have expected that automakers will seek out alternative materials for making electric car batteries. Why is cobalt such a big deal? Firstly, this mineral has an infamous moniker. It is called the blood diamond of batteries because individuals and companies have made fortunes from it. This mineral is the most expensive resource for making batteries, so companies like Tesla are looking to eliminate its usage entirely. According to Elon Musk of Tesla, making cars that people can afford is critical to the company's long-term goals. Unverified reports claim that by using cobalt-free batteries, Tesla will be able to make cars that are $10,000 cheaper. But why are other firms not following suit? As of the time of making this video, no plausible explanation has been given by any of the notable car brands. Despite the human right infringement of cobalt mining and the environmental risk such exploratory activities pose, BMW still went ahead to sign a long-term deal with Managem CTT, a Moroccan cobalt mining firm. This firm extracts the mineral from the only pure cobalt mine in the world, which is located in Morocco. BMW plans to use the cobalt from this mine to produce lithium-ion batteries for its electric cars. The MOU between both companies was signed in 2019, and the deal is worth $122 million, which represents about 20% of BMW's cobalt needs from now until 2025. The deal is earmarked to deliver about 3.9 kilotons of cobalt to BMW within 5 years, while Glencore will supply BMW with the remaining 80% worth of cobalt. While BMW and other EV car makers are trying to secure their supply of cobalt, Tesla wants to move in a different direction. During its Battery Day event, the company unveiled plans to build batteries in-house instead of purchasing them from battery manufacturers. However, no timeline has been given as to when Tesla will substitute in-house batteries for purchased versions. Every year, as much as 130,000 tons is mined globally, mostly as a byproduct of copper and nickel. With 2/3 of the global supply coming from the DRC currently, the volume is expected to rise this year and next because production did not halt. This is because the DRC, like many other African countries, escaped the harmful effects of the coronavirus. Compare that to the Ambatobi mine in Madagascar that was forced to shut down due to the virus. When you take a holistic view of the global supply chain, the long-term future of cobalt as an integral mineral for car batteries is not sustainable. Firstly, there is insufficient supply to meet the growing demand, which has continued to increase. The Marin and Bal-Azur mine containing cobalt that can't be used on car batteries if they are not chemically converted. Another challenge with cobalt is that more than 80% of global processing is done in China. After Glencore, Chinese firms are also large miners of the mineral in DRC. When you consider the geopolitical scheme of things and how China uses its control of the supply chain to protect its imperialist aims across the globe, this portends a dangerous economic trend for other nations. Even though the DRC contains more than half of the global cobalt deposit, the supply chain from the African nation is already saturated, which was why BMW had to look elsewhere for this mineral it so desperately needs. Tesla signed a deal with Glencore recently for a 6,000-ton supply from DRC, which will then be transported to its Shanghai factory. Despite its plans to move away from cobalt, this deal raises doubt regarding its seriousness to produce cobalt-free batteries. With many more electric cars expected to hit our roads in the coming decade, car batteries will continue to be in demand. Glencore, being a major cobalt supplier, has agreed several deals. It has a deal with SK Innovation to supply the Korean firm about 30,000 tons, which can produce batteries for 2 million electric cars. There is also a deal in place to supply cobalt to Umicore, a Belgian firm, and China's GEM battery recycler. Even without the Tesla deal, about 90% of Glencore's supply coming from the DRC for the foreseeable future has already been booked by automakers, recyclers, and battery manufacturers. The clamour for a new approach to making batteries has brought a new set of challenges. For instance, the call to end cobalt usage has raised the market price of substitute materials like nickel. People like Mr. Musk are advocating for nickel to supplant cobalt, and these calls have caused the price of nickel to surge significantly. But that is not the only problem stakeholders will have to deal with. Nickel is mined at more locations globally than cobalt, but the extraction of this mineral leads to environmental degradation and land pollution. In countries like Russia, nickel mining has polluted the land belonging to indigenous populations, and after significant pressure from rights groups, Elon Musk decided not to buy nickel from Norilsk Nickel, the company at the center of the storm. This experience of local populations in Russia is similar to what is obtainable in regions where nickel is mined. As long as cobalt remains an important material for building electric car batteries, the demand will continue to grow. Unfortunately, other materials considered to be close substitutes are no better, as they pollute the environment as badly as cobalt mining does. From the outside looking in, the world will not cleanse itself until we find a better way of doing things by improving our technology. Before finishing this video, we would like to know your thoughts about how EV batteries are made. Don't forget to subscribe. Take care. The deal is earmarked to deliver about 3.9 kilotons of cobalt to BMW within 5 years, while Glencore will supply BMW with the remaining 80% worth of cobalt. While BMW and other EV car makers are trying to secure their supply of cobalt, Tesla wants to move in a different direction. During its battery day, BMW plans to use the cobalt from this.
Thank you for watching, dear participants. Now we'll continue. So already we talked about around 8 number of challenges. And for all these 8 number of challenges, we have a potential solution and recommendation for all those challenges. So we'll see one by one. One is strengthening rural grid infrastructure for EV charging and strategies for strengthening rural grid infrastructure. And second one is limited three-phase power supply, voltage fluctuation and power outages, high initial cost, grid expansion, implementation of smart grid technology, public-private partnership and investment models, expansion of three-phase power supply, policy recommendation for strengthening rural grid infrastructure. So these are the solution for the above set challenges. And here the challenges in rural EV infrastructure development: high initial cost in investment cost, uncertain profitability, limited grid capacity infrastructure, regulatory and land acquisition hurdles. And third is role of public-private partnership in rural EV infrastructure. Now, type of PPT models, that is public-private partnership models, type of triple P models for EV infrastructure. Build operator transfer, BOT, joint venture model, subsidized private investment, government-owned private operator, GOPO, government-owned private operator. And next one is government incentives to promote rural infrastructure. In this category, we have a financial incentives has to be given, capital in terms of capital subsidies, low interest loans and credit guarantees, tax exemption and rebates. And next point is, after the next to the financial incentives, the policy incentives has to be created. The subsidized electricity rate for EV charging, faster track regulatory approvals, land allocation for EV charging station. And next one is, next to the policy incentives, support for renewable energy based charging station. So this will encourage the solar and wind power EV charging station, microgrids, battery storage, hybrid energy solution station. And successful case, there are certain successful case studies of PPP and incentives in EV infrastructure. India's FAME2 scheme, United States federal EV infrastructure incentives. Third one is China's public-private model for rural EV adoption. So these three case studies will support the EV infrastructure policy. And third one is deployment of low-cost charging station and deployment of low charging solution for rural EV infrastructure. One is challenges in deploying traditional EV charging infrastructure in rural areas. High initial investment is required, inadequate grid capacity, limited land availability, low EV penetration. So these are the points has to be taken into account. And next one is low cost charging solution for rural areas. Solar powered EV charging station, that where the solar energy is ideal solution for rural areas for limited grid connectivity. Standalone solar charging station, that means to use the PV panel, battery storage, which reduce the dependency on the main grid. Government and private investors can deploy a small scale solar grid at strategic locations such as markets, village centers, and transportation points and hubs. And the advantages due to creating the solar powered EV charging station is no resilience on unstable grid, low operation cost after the initial setup, scalability and sustainability. This is the first point. And second one is battery swapping station. So which the advantage of the battery swapping station, low infrastructure requirement, there is no high power grid needed, fast energy replacement compared to charging, and affordable deployment in multiple locations. The third point is low cost AC slow charging station. The advantage of this point is that means the advantage of low cost AC slow charging stations, lower installation cost can be integrated to existing grid infrastructure and ideal for home and community based charging. So the community based charging and home based charging will be very effective for the person, those who are having the own four-wheeler or three-wheeler. And community based charging hubs. So this has some advantages, reduces the individual setup cost, support multiple user with shared infrastructure, encourages a cooperative and cooperative ownership models. And next one is mobile and portable charging units. So this will have some advantages. This will eliminate the need for permanent infrastructure that can be transported based on demand, useful for seasonal and agriculture EV use. And next one is government support and incentives for low-cost charging solution. And this will have a subsidized land for charging station, tax breaks and grants, microfinance for small business, public awareness and combines and fifth one is successful example of low-cost charging deployment. India solar powered charging station FAME 2 initiative, China battery swapping model for rural areas, Kenya community charging hub for electric motor vehicles. And next one is awareness and skill development program for rural deployment. Awareness and skill development program for rural EV adoption. So this will have some key points. Importance of awareness and skill development program has to be given to the public. Lack of awareness about the EV in rural areas. Shortage of skilled workers in EV sector. Economic opportunities through the EV skill development. And key components and skill development program has to be conducted with, by community awareness combines and training programs for EV mechanics and technician. Skill development centers has to be open and should be offered specialized training on battery management and diagnosis system, diagnostic, motor and controller repairs, charging station setup and troubleshooting. And next one is educational institution initiatives in schools and colleges. So by introducing this EV technology courses in technical institute, polytechnic colleges and vocational school can help can equip the students with the relevant skill. Collaborating with automotive companies, universities and local governments can promote the hands-on training program. And next one is digital awareness campaign, like education initiative in schools and colleges. The digital awareness campaigns has to be conducted through mobile apps, online workshop, social media campaigns. Informative videos in local language has to be published. Government and industry initiative to support the awareness and skill development. One is government-led awareness program through a national and national and state level combined, subsidizing workshop and training program, setting up EV rural demonstration center. Next one is public-private partnership for EV training. Next to this one, incentive for EV mechanics and charging station operators. And there are certain case studies like what we discussed earlier for successful awareness and skill development program. That means this case studies has to be conducted by India, China, and Kenya. So India's Skill India initiative for EV training, China's vocational EV training for rural areas, Kenya's solar EV charging training for local entrepreneurs. Next one is awareness and skill development program for EV adoption. An importance of awareness skill development program. Shortage of skilled workers in EV sectors. Economic opportunity through the EV skill development. There are some key components of EV awareness and skill development program. Community awareness combines training program for EV mechanic and technician. All this we discussed already. And finally, is expansion of EV friendly policies. Expansion of EV friendly policies. First one is importance of EV expanding EV friendly policies. Key areas for EV expansion, EV policy expansion. One is subsidies and financial incentives. strengthening the charging infrastructure policies, and rural electrification and grid modernization, regulatory reforms and standardization, consumer awareness and incentive program, and next one is strategic for rural effective policy information. So this come under this strategic for effective policy information. We have a PP, a PPP, and special economic zone for EV production, integrating EV policies with renewable energy goal, expanding EV financial option, data-driven policy making. The case studies for EV policy, successful EV policies was carried out by Norway Comprehensive EV Policy Framework, India's FAME, that is faster adoption and manufacturing of electric vehicle scheme, China's EV expansion model. So these are the initiative we already under process and already carried out by the government of Norway and India and China. And these are the points we discussed on the challenges in rural electrification for EV infrastructure. Have any queries or any doubts, please?
Dear participants, do you have any clarification of what is raise your queries and clarifications? The speaker is happy to answer the same. Dear participants, dear participants, is there any queries? Okay, many of the participants has put the thank you. Very nice presentation. Research coordination, PPT. Watching very nice presentation. Sundararajan, thank you, sir. Good morning, madam. Feedback from please. It will be given by 9 o'clock. Don't worry. In chat box, it will be posted. Don't worry. If there are any queries, let us move on to the Thanksgiving session. Professor Dr. Vijayan, Professor of Mechanical Engineering of our college, Sundararajan Engineering College, and also the co-coordinator of this FDP online program says energy sustainability and climate change trust area. The topic is energy and electrical vehicles in India, opportunities, challenges, and future. The session setting was very interesting and informative one. Challenges in rural electrification for EV infrastructure, he has explained very nicely, and participants also we have clarified the same. So on behalf of AICTE ATAL online FDP program and on behalf of the management and the college authorities of Meenakshi Sundararajan Engineering College, we express our sincere thanks from our core of the heart for today's expert speaker, Dr. Vijayan sir, for the informative session. Thank you very much, sir.
Thank you, sir. Thank you, sir.
So with this fifth day session is getting over. An important announcement. Tomorrow is the last and sixth day. Participants, please note. Tomorrow is the last and sixth day. Session starts by 2 p.m. not by 6 p.m. Session starts by 2 p.m. Session 11 is 2 p.m. to 3:30 p.m. And session 12 is 3:30 to 5 p.m. And again session 13 is 5 to 6:30 p.m. And important thing is 6:30 to 7:30 online test and feedback. And 7:30 to 8 it is a validity session. Again I repeat, dear participants, please listen carefully and understand carefully. As per the ATAL online FDP program, 80% attendance is mandatory and 70% marks are mandatory. Tomorrow is the last and sixth day. Tomorrow session starts by 2 p.m., not by 6 p.m. as in regular 5 days. Tomorrow being Saturday, session sixth day session number 11 starts by 2 p.m. to 3:30 p.m. It is going to handle by the Dr. A. Krishnavani, postdoctoral fellow member of Tokyo University, Tokyo Technology of Science University, Japan. And her topic is battery technology and recycling challenges. Followed by session 12 is going to be handled by Professor Dr. R. Velraj, the Professor of Energy Engineering Department and also the former Vice Chancellor of Anna University. That session timing is 3:30 to 5 p.m. Followed by session 13, that is 5 p.m. to 6:30 p.m. Again is going to handle by our co-coordinator, Professor Dr. Vijayan sir, in the topic of the consumer perception and the acceptance of EVs. That is the last and 13th session, followed by the long awaiting examination, that is online test, which is necessary to get the certificate and to get more than 70 marks and above. That is going to happen in online mode in between 6:30 to 7:30 p.m., followed by feedback session. I already requested those who want to give feedback, kindly give your one-page biodata in a PPT form so that we can arrange it, order it, we will call one by one. We will finish that section in the estimated time. Followed by last session is 7:30 to 8 p.m., half an hour. It is a validatory session. Thank you for your understanding and cooperation and attending in large numbers. Almost today the online participants is more than 147. So every day it is crossing roughly 150, though the registered participants are 250 plus. So once again, on behalf of the ATAL FDP online program, on behalf of Meenakshi Sundararajan Engineering College, Department of Mechanical Engineering, myself, the coordinator, Professor Dr. S.V. Saravanan, Principal and ATAL FDP coordinator, and my beloved co-coordinator, Dr. Vijayan, also Professor of Mechanical Engineering of Meenakshi Sundararajan Engineering College. Once again, thanks all the participants who have come all the 5 days in online in a successful manner and benefit in the area of the energy and electric vehicles, challenges and futures for the past 5 days, and also the tomorrow last and sixth day. Please be present by 1:45 p.m. in online. Tomorrow it is going to happen by afternoon, not by evening 6 p.m. It starts by 1:45 p.m. and ends by 8 p.m. Please see the schedule once again. It is also posted in the group, participants group. Thank you very much. Good night. Jai Hind.
Jai Hind.